this is the king of fruits of India, or the fruit of India, I would say, the national fruit of India, and which has gained importance all over the country. And I think every state, I would say every province has different varieties of mango. I would say there are more than 1,000 varieties, which which speaks of the huge biodiversity what we have for mango, including, I would say, the best of the best fruits could be for table purpose, or for pickling purpose, or for making the pulp and juice and things like that. All these things, I would say, add value, especially for mango. Mango season, once it comes, probably people don't prefer any other fruit other than mango. That is the problem here. I would say that because as a food processor and a value addition expert, probably I think we need to look at how this can be made available throughout the year. That is something which is what I would say is required today on in the present day context. I know India being a huge country with huge production of 21 million tons, our exports are still, I would say, very, very minimal. And excepting these days, in the last few years, we have been exporting the fruit, especially mango, to some of the Gulf countries, and to a certain extent some European countries. We have started opened up. Maybe there are some issues with this. Maybe we are not sticking on to the international standards on one side. Maybe the pesticide residues are creating a problem. Things like that, which are creating a big problem. Of course, we do have a variety called Alfonso, which is the king of mangoes, I would say. Supposed to be very tastier, and it has a huge international demand. But unfortunately, I think this has not been properly conceived to preserve its quality and to preserve it for a longer period. And that means the shelf life has to be increased. So how do we do that? Probably, I know we are now, in fact, we have been discussing every day. So how do we improvise the modern infrastructure? Could be in terms of pack houses, could be in terms of the storage facilities, or even the cold chain logistics, things like that, which are very important from the processing point of view. Not only processing, even for table purpose also. Now, out of these 21 million tons, if we can even process 10% of them, that is a huge quantity, which can really help us to taste mango even during the off season. That is something which is very, very important for India. Of course, the global trade is not that very in terms of mango. I would say it is about 271 crore rupees, which is a very small amount, I would say, as compared to other like basmati rice and things like that, which are being exported from India. And of course, the major problems, of course, as I said, it is the short shelf life. I know once the fruit matures, the shelf life is very, very small. And within, say, about 1 month or so, it has to be consumed. Otherwise, it doesn't have that keeping quality. Second thing, of course, even if you are keeping under low temperatures, probably the formation of ice crystals is a major issue in mango. And we will not be, once it is thawed and all that, it will not retain the same original taste. That is another big issue which we have. And of course, chilling injury is a major problem. And of course, in the late varieties, anthracnose has become a major issue. So this is where I think people do use a lot of pesticides, which create more problem even for processing or value addition or even for export. And of course, I would say the pesticide residue is another big problem, which otherwise, in fact, many of these consignments which are sent to other countries are getting rejected because of this. So otherwise, I think we have a bright future ahead, and we need to look at the positives of that. Maybe adoption of latest technologies, which is becoming. I would say India is really giving a lot of impetus through maybe the Ministry of Food Processing Industries, through the Natural Horticulture Mission, and the National Horticulture Board, things like that. Huge amount of money is spent, especially on the infrastructure part of it, to improve maybe the pack houses, or maybe the refrigeration, or a solar driven refrigeration systems on farm. I think these are things which we need to look at, of course, and the logistics in terms of maybe the reefer vans and things like that. I know even the trains. Now we have introduced trains for transport of the perishables to different parts so that it is a refrigerated truck where it can be maintained, temperature can be maintained to meet our requirement, and it can be transported. This is another big incentive, or I would say initiative of the government of India, where we are trying to take forward some of the issues. And that apart, I think, see the biodiversity maintenance and improving the keeping quality, or I would say maybe I think even off-season varieties need to be explored. Anyway, they're already there. Now I think throughout the year we get, but not in sufficient quantities apart from the major seasons, April, May, June. So that is something which is, I would say, very, very important. And of course, different another very important thing is we have a huge number of small and marginal farmers who produce a lot of it, and how do we reach them? Maybe I think there are concepts like the contract farming and things like that, or the gathering processes that are happening, and the mega food parks are coming up everywhere. Now probably this is one area where we need to give a major focus. And that apart, of course, I know since we produce a lot, the loss is very heavy. The post-harvest loss is something like 20-25%. How do we reduce this? How do we add value to the product, and how do we improve its, and I would say the availability throughout the year? I think these are some of the important issues which we need to really focus. I wish this body will give importance for some of these issues, take forward, and maybe I think that's very important for Niftem as well. A huge number of students who will be researching on some of these things, and probably that would be a big lesson for all of us. Take it forward to learn things, and also to see that how best we can push ahead in terms of making mango available throughout the year. Maybe you have the mango sticks and the mango leather and things like that, which I would say are not like mango. That is something which really the Indian palate doesn't cherish. All the same, keeping mango safe, good, and with good quality and safety, everything, I think is becoming very, very important. So with this, I thank each one of you again for your kind participation, and it's a great pleasure to have all of you and to learn from each one of you on various aspects of, I would say, mango post-harvest processing and value addition. Thank you very much. All the very best.
Thank you very much, sir, for your kind words and for the permission to organize this important event. Now we have slight change in the order. As Professor A.K. Singh is busy in another meeting and he will join after 15 minutes. So I first invite Dr. Shailendra Rajan, former director of the Central Institute of Subtropical Horticulture, Lucknow, who will be speaking on the diversity, genetic resources, and world's leading cultivars. Dr. Shailendra Rajan has over 36 years of research experience in mango breeding and genetic resource management. He worked in various capacities, starting from scientist to head of the division, as head division of the crop improvement and biotechnology, and superannuated as director of the Central Institute for Subtropical Horticulture in Lucknow, India. He has contributed outstandingly to the genetic resource management of mango and augmented and maintained one of the largest mango field gene bank in the world. He has widely traveled in mango growing areas of India and abroad, for example, China, Thailand, Malaysia, Philippines, Oman, Nepal, etc. Dr. Rajan has had the honor of working as an IPGRI consultant for the status report on genetic resources of mango in the Asia Pacific region in 2000, coordinator for the development of a website on the Asian Fruit Genetic Resources Network for 10 countries, resource person for information documentation of tropical fruit genetic resources and use of GIS technology, member of various task forces for DUS guidelines for fruit crops, nodal person for DUS testing of mango. He was instrumental in developing community-based organizations like Society for Conservation of Mango Diversity in Malihabad. He is a fellow of 5 professional societies, including Indian Academy of Horticultural Sciences, Confederation of Horticultural Associations of India, SADH, ISHRD, President of the Society of Advancement of Subtropical Horticulture. Dr. Rajan is distinguished scientist and has been awarded several awards and recognitions from national academies, societies, and farmer organizations. These includes the Shri Girdhari Lal Chadda Award, Lifetime Achievement Award, and R.S. Paroda Award. So he is the a real scientist who was worked for the 32 years in the mango crop, and also he starts his MS thesis on the mango and then PhD in the mango, and then served his whole life for the mango. He said that his first life partner is mango, and after that someone else in his life. So I invite Dr. Shailendra Rajan for his brief presentation on the diversity and genetic resources and world leading mango cultivars. Sir, now the floor is yours. You can
Hello.
Yeah, we can hear.
Can you see my slides also?
Yeah, we can see your slides also.
Okay. So as Dr. Parikh has already introduced, the topic is somewhat very interesting because the India has the origin from, mango has origin from India, as well as if you see the most mango producing area, the most of the tonnage is coming from the Asian countries. And it is directly related with the diversity also, which is available here. In other parts of the world, except Florida and other parts, most of the countries are new in growing mangoes. Therefore, the diversity is also less, as well as most of the varieties have been introduced from different parts of the country, from the different parts of the globe. First of all, the mango varieties moved from India to other parts of the world in 16th century. They tried it, but afterwards, gradually, people could not pick up it well in different parts, and mostly it was a somewhat exotic fruit. Now it has become a commercial fruit in many of the world countries, and if you see the statistics, about 140 countries are growing mangoes. So in some of the countries, it has become a export commodity also, and people are not growing mangoes for their own consumption, or the consumption is too less, but they are exporting the major quantity. But in India, lot much diversity is available. In Asian countries, Southeast Asian countries, lot much diversity is available. And gradually, China is also coming up with the varieties, and most of the diversity has been collected from India or other parts. The varieties which traveled from India to African countries or Florida, those have played a role in giving birth to the new varieties. We will discuss about it. But if you see how the mango diversity has come up with the leading varieties which are available for the commercial cultivation, here the most of the varietal development work started in the as a natural laboratory, and we find that in India there were several places where development of the varieties took place due to the interest of the people, the kings, nawabs, and most important, the nurserymen. You can see how many varieties are there, no one can count. Each and every stone gives a birth to a new varieties. But we can't say that we have infinity number of varieties, but several varieties which are identified by people must be more than 1,000, and commercially grown are more than 30, which are being grown at somewhat several hectares acreage. But if we see the major important area which took place in which played a role in developing the mango varieties was from Lucknow, Saharanpur belt, again then Murshidabad area, and Nawabs were interested in Hyderabad area. So most of the places where the Muslim rulers were interested in that, they exchanged the mango varieties from different parts of the country. Initially, they were growing seedlings, but afterwards the grafts were made, and you all know Akbar, the great Akbar planted this 1 lakh plants and in Darbhanga, that is called as Lakhi Plug. Even that today, lot of wild types in mangoes, wild types of mangoes are available in India in different parts of the country, and mostly in Manipur, Tripura, Mizoram, other areas, Chota Nagpur, then Santal Pargana, in Andamans, and some of the peninsular area, peninsular Indian regions also. So this is the diversity available. You can see the bunches, how profusely it is fruiting. It has a lot of value, particularly for the rootstock breeding or for the improvement of the mango. And here at the lower part, the 5 number, that is in giving you a picture how these varieties are being utilized for the pickle making. The entire mango, the intact mango is pickled and it's processed during the tender stage. That's why it is called a APBD. So these are some of the varieties. Dashari, it is the most ruling variety of North India. And now traveling to the different parts of the country, it has gone to Gujarat, people are growing. In Maharashtra, in Odisha, people are cultivating the sherry. And in Andhra Pradesh, the sherry is about 1.5 months early as compared to its traditional area. Langra, it is one of the important varieties. It has gone to the Pakistan and they are having export value of it. The sherry also, Chausa also. Chausa is in international market also. And it is mostly grown as a summer Bahish Chausa in Pakistan. New are 2 of the hybrids which have come up, Amrpali and Malika. These are the hybrids which were evolved in 70s, last century, but those are coming up as a commercial variety so late. And this is the story how the mango varieties are not replacing, new varieties are not replacing very easily. It takes time because due to the several of the reasons, the long juvenile period or the multiplication rate or the mother plants required for the large multiplication of the planting material. But I should say, a lot of variability has come up in Dashari. You can say Dashari clones are there. We have about 50 clones, lot of variation in fruit size, fruit shape, then time of maturity, this you can see. This type of thelas you can find in India, where not only one variety, there may be several varieties displayed on that. People are purchasing it, relishing it, and the entire season is for the mango. Here I am showing you the starting from the chimera and other different types of skin, this skin where the protuberances are there, just like some of them are just like Karela. And these all varieties are very, very attractive. The color variations you can find, the shape, taste, aroma, many things you can find out of it. And but most of them are now disappearing. These are some of the important varieties. Sorry, it is not the cherry. It is Alfonso. Sorry, it has been made. The cherry. This is the cherry. This is Totapuri. Then this is a Lucknow Sabeda, a sucking variety, and Ratal. This is a variety which has been very much valued in Middle East, and it is a variety known as Anwar Ratal in Pakistan. It is one of the very, very aromatic varieties. I am giving you example. The farmers has played an important role in conserving the mango varieties as well as their participatory role in breeding. I should say the farmers level breeding in case of mango has taken place. This is one of the example where you can find 564 varieties were conserved by farmers. We studied about 10 years back. These varieties were conserved by the farmers in their own orchard. And this is the reason why the new varieties have come up so in good numbers in India as compared to other parts, because these varieties are being grown through seed as a seedling, and people are still maintaining it because these varieties doesn't require much input, and gradually now people are interested to have those varieties which are rare. Commercial varieties are easily available, but these rare varieties, they want to purchase, the consumers want to purchase, and they consume, and they are ready to pay 2 to 3 times more price than the sherry or other commercial variety. These are some of the varieties which have already have the GI, geographical indicator. Alfonso, you all know from Ratnagiri, the sherry from Maliabad, Bangnapalli for Bangnapalli. Then APMD, this is a typical pickling variety, or this is a pickling type. Many varieties are in pickling, this APMD, and these are from Sirsi and the coastal Karnataka. This has lot of export value because this pickle is being exported to different parts of the world where people relish it, and it is had a lot of export value of crores. Then Himsagar, this is a important variety from West Bengal, being grown there, but it has also GI. Then Gir Kesar, the Kesar variety it is now replacing at many places the Alfonso also, because of its better bearing habit, and the people are now liking it in the international market also. Fajli, not very good variety as far as taste and keeping quality is concerned, but it is a dominating variety going to Bangladesh and other parts in West Bengal. It is very much relished. Then Kohitu, this is a variety, it has also been provided GI, geographical indicator. Rathol recently got this GI from Western UP, Rathol village. Then Marathwada Kesar, it is somewhat different from the Gir Kesar. Lakshman Bhog, it is a colored variety. Then Jardalu from Bihar, it is a Bhagalpur. This is an excellent example of the traditional varieties which have lot of value. Initially, there was lot of problems in exporting these varieties. Now people are asking for these varieties in Middle East and other countries where people could learn how these varieties are tasty, and these varieties are not only attractive but tasty also, and they like its aroma, taste, and many other qualities. These are the varieties in India which have been given geographical indicators. I am not going in detail, but you see in different parts of the country, different regional varieties are there. That's why a lot of adaptability is there for these varieties, but many of the varieties have a specific adaptability. This is the somewhat problem with the Indian varieties. I should say problem, or these are specific, that they can be grown, they could be grown in a specific region, particularly for as far as quality is concerned. And the consumer preference is also changing as per the locality, the variety. So people relish different varieties. The Jardalu is liked in Bihar, sub part of West Bengal, but the varieties from Andhra Pradesh, those may like some sucking variety, those may not be common in other parts of the country. But some of the varieties have become very, very prominent in other parts also, and those are commercially being grown. Now, most of the international market is dependent on the red peel color. And if we see the red peel color, that was dominating in the international export market. Most of the Floridian varieties or the Latin American countries, they are growing the red colored varieties, and those varieties are not having that much TSS, not that high sugar, as well as the carotenoid content may be less, but their storage is very easy, the shelf life is higher, and they have better markets, international markets. And in European markets and American markets, they are dominating, but gradually some of the varieties which are yellow-green color, like a Talfo, those have entered in US markets also. And after tasting these fruits, people now liking, they have now no myth that only red colored varieties are good. Now the things are changing. Particularly Asian consumers are very, very specific. They know about the variety, their overall understanding is good, and they try to purchase it on the basis of the its appearance, color characteristics, and yellow and green colored varieties are also preferred by them. So people have developed preferences as per the local varieties available, and many of the varieties have traveled from one part to other part of the country, and those like Alfonso, it is becoming common in different parts of the country. Kesar also dominating. Dashari growing from northern parts to other parts, because people from belonging to northern part, they are in metros in different parts of the country. But the local varieties are getting sometimes premium price than the commercial varieties also. And like Gorjite variety from eastern UP, that gets a very good premium price as compared to the Shari. So this scenario is also changing in international market, where the Atalfo, a variety which has been introduced in US, that has played important role. Now it is replacing several of the red colored varieties. People are interested in that, and the value of bioactive compound has made many mango varieties very important. Bioactive compound like this lupiol and mangiferine, those have become important for as far as our health is concerned, immunity system is there concerned. So people are interested to have those varieties which has higher value of these both the bioactive compounds. Then if I said already I mentioned that the Floridan varieties also have the Indian connection. The most of the Floridan variety, they are related with the Hayden, and about several dozen varieties are descendant of the Hayden variety. The variety which came as, we should say, a offspring of Malgoa. People used to say the Malgoa, but Malgoa doesn't have color. But we presume that the root stock has come up and the root stock fruited well. And this is a very, very great probability of getting higher number of promising type from this Floridan variety that is hidden. Tommy Atkins, Palmer, Austin, Kent, Keat, Sensation, all these varieties have come up out of that. And these are ruling varieties in the international market, particularly Keat, Kent. Then Sensation, it is now being not much preferred because of the this patches developed on the skin. Again, the Tommy Atkins, it is still ruling variety, but the variety is now being replaced at different parts of the world. Many other varieties are playing role importantly, like in Carabao in Philippines. This variety is being exported to Japan and other parts. This potassium nitrate technology worked with beautifully with the Carabao, and people are growing Carabao there and most of the time exporting. It is a very good looking variety as far as fruit is concerned. The fruits are clean, good in quality. Then Atalfo, which has made important dent, and we don't know whether it is from Malaysian origin, but in Mexico, it is coming up with a larger area. The Knobdok Mai, this is a Thai variety, particularly being exported to different parts of the world, Japan, sometimes it is going to China also. Kensington Pride. The Kensington has been the leading variety of Australian mango industry, and it has been also utilized for the breeding purposes. And Kensington and Kensington Pride, these have been the major variety for the mango production, particularly in this country, and export also. This variety is also polymorphic, and most of the Carabao and other varieties from Southeast Asian countries like Namdok Mai, these are all polymorphic. That's why in this area, diversity is that not much high as compared to India. India, most of the monobronic varieties have been grown in the orchards. That's why diversity is high. Lot many varieties have been evolved, but here narrow genetic base is there in Southeast Asian countries and in some part of the China also. So these are some Israeli breeding work has also come up. These varieties have been protected also, patent have been taken, but this Israel is also having the parents from the Floridan varieties. This is one of the example I am giving you, the diversity this is a diversity available in our laboratory. On the single day, these many fruits were different types were available. We tried to evaluate these varieties for particularly two compounds, mangiferin and lupiol, and we found lot of variation is there. Some of the varieties are having very high content. Mangiferin, it is very high in Arunica and Ambika, whereas in Alfonso it was less. So these are some of the factors which can be having more important, particularly if the products are made from these varieties, and we can have some specific mango varieties for specific purpose. This I am showing you one of the schematic presentation for particularly mangoes. Here the varieties, as you have seen, lot of differences are there, particularly the varieties. Some are smaller, some may be not having good market value, but the diversity in the market is only available for export. That is very premium one, which has have high value. But the lower value, the localized, those are consumed by the localized market, or some of the diversified markets are there, but limited market values are there. But these are very much related with the livelihood of the people, the tribals and others. They utilize this for making their local dishes. Their recipes are different. They dry also sometimes mango. Many things are made. But if we want to process it, so we have to think about the B this category, or the D category. In most of the time, fibrous varieties are there, but specific dietary fiber rich products can be made out of it. And the C category may have different types of products, that the variability in the products can be exploited. And these are very much having high content of the bioactive compounds, not only mangiferin, but several of the isomers. So this can be exploited not only for the home consumption, this can go for the processing also, but that depends on the product which we are going to make. The high local market value, these can be consumed because the very high value of the mangoes cannot be afforded by the processing industry. If the mangoes are 100 rupees a kg or 80 rupees a kg, the processing industry can't afford it. So this is some of the work we did for the processing, how the suitable varieties are there for pickling, how those can be multiplied. So pickling is one of the industry which is having a lot of value. Crores of revenue we are getting out of pickles from India, and Indian pickles are liked in different parts of the world. So we worked on that. So processing is one of the important area, particularly for pickle, which type of varieties are important. These are the varieties not looking good, but these varieties are having better price, sale value. This is a Ramkela variety. These are Ramkela variety fruits, and these are sold at a higher value, I should say, value as compared to the sherry also sometimes. Sometimes the sherry is 25 rupees a kg. This is at 40 rupees a kg. And gradually these type of varieties are disappearing, which are very, very suitable for the pickle making. And pickles made by from the specific variety are very, very specific, and people like it. I like it. General pickle making varieties from the seedlings is a general, somewhat common in industry practice, but best quality pickles are made from the varieties specifically, just like Ramkela and Aswina in West Bengal. These are varieties which have high acidity, more fiber, then they can be retained for a longer period. They don't develop carotenoids after harvesting also in a short time. They can be very much stored before pickling also. So this is one of the work done by our one of friend Dr. Vasudeva. That this much variability is in AP type, AP Medi. This is aromatic pickle type, which is having a crore of rupees industry for pickles, and these are exported, and these are unique varieties. The aromatic value of the these varieties, it fixes the price, and the more aromatic variety has higher value in the market, and people test it, how the aromatic value can be, and then with a simple traditional knowledge. So this is the variability in there, and these fruits are consumed at the early stage and directly pickled. The entire fruit is pickled. It is not cut down, cut into pieces, and this pickle is being very much relished in southern parts of the country. So the varieties have the diversities being conserved in the orchards. We used to have this type of diversity fair in the orchards. Many people used to go there and see, they visit which type of mangoes are available. And this activity is very much important because this promotes the conservation of the varieties. Otherwise, varieties will disappear. Tomorrow, many of the products may come which may be dependent on the specific variety. And if you want to multiply those varieties, you will not have the planting material, the mother plants, the sand. So it is very necessary, very much necessary to get these variety conserved and also get exploited for selling the fruits. Because the farmers, if they don't get a good price of these varieties, they are going to cut it. So we tried it, sending the varieties from north to Kerala, and about 600 varieties were displayed in Kerala, and people relished it. A variety which is sold at 20 rupees a kg in north at Lucknow, that was sold at 150 rupees a kg. So these are some of the effect of the places, and people want to taste different types of variety. This is one of the example in one box we can have about more than a dozen variety. Different types of taste is important. It is coming up as one of the practices for delicious also. People are putting different types of apples, different varieties of apples in a box, and these mixed variety fruit box are becoming important. And in mango, it is important when the diversity is available and it is only possible if the varieties are available. So for saving the varieties, we have to do this type of thing. So this is one of the example of the children, how they perceive. This is a rural school, village school, which is situated in the area of diversity, and the students have made this type of diagrams after visualizing, seeing the diversity, and this is they have shown, and we have made a collage out of it. These are Malihabad children, how they can visualize it and how they see the mangoes. This is the diversity in mango, and lot much diversity, not only shape, size, color, aroma, fiberiness, and many of the things which we can't even assume. Thank you very much for patient hearing.
Thank you very much, sir, for your colorful slides and all the colors of the mango and the taste of the mango given to us. Now I can see that our Deputy Director General Horticulture, Professor A.K. Singh ji, has joined after completing his previous meeting. So we welcome you, sir, here in this meeting. Dr. A.K. Singh, as I told you, that he is the great scientist and the policy maker who is giving the new heights to the horticulture industry in India. And presently he is the Deputy Director General of the Indian Council of Agricultural Research, which comes under the Ministry of Agriculture, Government of India. He was the postdoctorate from Saga University, Japan, and University of California, US. He was worked as at Tata Energy Research Institute, TERI, New Delhi from 1991 to 98. Then senior scientist at Indian Institute of Vegetable Research, Varanasi. After that, senior scientist in the Division of Fruits and Horticulture Technology, where he rose up to the principal scientist and head of the division. And after that, he given impetus to the horticulture industry as a managing director of National Horticulture Board and chairman of the Coconut Development Board, as well as the executive director of National Oilseeds and Vegetable Oils Development Board, that is NOVOD, Ministry of Agriculture and Farmers Welfare, Government of India. His major research areas are genetic improvement and plant tissue culture and transcriptome analysis of fruit crops. He has spearhead major research work and published more than 150 research papers in international and national scientific journals. He is recipient of many awards, which include the Mombusho Award by the Japanese government, Award of the Ministry of Human Resources of Government of India, and Visiting Scientist Award from the Association of International Education Japan, and the DBT Overseas Association Award. He is Fellow of National Academy of Agricultural Sciences, National Academy of Biological Sciences, Horticultural Society of India, etc. His research area includes the tissue culture and plant molecular biology of horticultural crops. And presently he is serving as the policy maker, that is the highest body, Indian Council of Agricultural Research, as Deputy Director General of Horticultural Sciences. We welcome you, sir, here in this webinar, and we're thankful that you have agreed for your remarks to all of us, despite of your busy schedule. And I know that you just joined in this meeting after completing your another meeting with the US friends. So we welcome you, sir. And now you can give us your thoughts, and we will really value your thoughts, sir. Professor A.K. Singh. Sir, unmute, please. Sir, you are muted. Please unmute. Sir, unmute.
Unmute. Yeah. Thank you so much. Now I think I am audible to you. Can you hear me, Sunil?
Yes, sir, you are audible, sir.
Oh, thank you so much. I'm so sorry. My apologies first that I got delayed for this program, although I had my commitment to you. I mean, of course, long time back. But this meeting came in the middle, so it was not in. I was not in a position to skip that meeting. Thank you so much. But very good evening to all of you. When such a wonderful topic you have chosen, Dr. Sunil, to a wake-up call for the post-harvest management and value chain development in mango. When we are here with the global community of the mango, those who are associated with mango in various capacities as a researcher, as a processor, as a value adder, investor, or as a scientist also, as a professor of mango in horticultural sciences. And to grace this occasion, we have with this very august membership, Dr. Vasudeva, Honorable Vice Chancellor, Niftem, Dr. My colleague who was just superannuated from the Central Institute of Subtropical Horticulture, Dr. Rajan, Dr. Garcia from Mexico, and Dr. Yahia also from the Mexico. Dr. Srikanta, Dr. Manuel Michael, I think US, I think whether he could join or not, I'm not sure. Sunil Prarik, very good friend of mine for so many decades now. And thank you so much, Sunil, for giving me this opportunity to speak on this particular occasion, which is so close to me, that is so important to us, so important to the farming community as well as the consumers of India also. You know, the mango production, we have made so much improvement in case of mango from production, value addition, processing. If I compared the data 20 years back and 25 years back, and Dr. Rajan has just made the presentations of the amount of diversity that we have and how we have deployed these diversity into the development of new varieties and the matching production technology which has gone to the stakeholders. In fact, we made our strong connections through these technologies, and we enable farmers, mango farmers, to cultivate them in different climatic zones. As a result, the new varieties or even the older varieties also have been we have been able to cultivate them in the larger areas, in non-traditional areas also, with the great benefit. But the production itself is not a very fair idea in view of a few things. Number one, that unless the farmers get the right profit, right remuneration from the enterprise mango, either as a cultivator or as a processor or either as an investor in the mango industry through supply chain system, through the store system, or in various other ways. So there are certain things. Indian agriculture has moved so fast, and along with that, horticulture has also moved in a different league where we are producing. In fact, we are overproducing. So the overproduction is not going to offer the solution actually, unless wherever feasibility exists, the right kind of processing tools are available, right kind of ambience is available, right technology is available at the hands of the investors. Otherwise, this is not going to serve as a very important tool to promote the mango industry of the country, or for that matter, any part of the world. We have been able to raise the productivity through production and raising the suitable varieties, management options we have resorted, and also the right kind of push from the policy agencies, particularly the local as well as the national and the local government also. Despite these, some of the challenges, despite we produce such a massive amount of mango, very small portion, less than 8% is under processing. So, there are many areas in the mango growing season, mango harvesting season in India, the farmers do not realize the right amount of profit out of mango enterprises. This is where farmers This is where mango growers, they face the problem. And at times, they are in a dilemma whether to continue with the mango or not. But as you know, that the mango is a perennial crop. Once planted, it's very difficult. It's a very tough decision to quit mango cultivation. So despite sometimes losses also, farmers do diversify mango areas with some other crops so that it increases, it raises the remuneration from the same piece of land along with the mango, despite in the glut scenario when the mango is not being sold out at the right price. And all over the world, the input cost is rising. Scientific innovation is also rising. And the high value crops, particularly including mango, the cultivation is knowledge intensive, technology intensive, and it also needs the running capital on a regular basis. So it needs one wherever there is so much of capital involvement is there and right kind of opportunities are not there for value addition or processing, then there are some occasions where the mistrust in the mind of the farmers arises. So we as the technical stakeholder of the mango in the world, in India, we have to come up to the expectations that to develop right kind of the processing system for the mango so that a variety of the processable a variety of the processed commodities can be generated, produced at a competitive level with a great amount of safety for the health. Otherwise, this is going to face a difficult challenge in days to come, like in the yesteryears. Now, since we are producing mammoth amount of the horticultural commodities and the food grain also, despite that massive amount of population in India, more than 200 million population is suffering from malnutrition. And mango is a storehouse of the variety of health beneficial compounds in it. Therefore, the consumption has to be increased either in a fresh format or in a value-added format in India and outside India also. Unless our great portion of the mango is really made available to the consumers in a safe way it is processed for other countries, it will be difficult to achieve our target. And therefore, role of these technical stakeholders comes to assume a very significant position. When we look at the mango industry of India, there are many challenges. For example, the international market demand, global gap certification in the orchards, for example. I have noted down some of the points, which pose a problem for both the merchant exporters and also the farmer exporter. And a large-scale awareness creation is required in India. Many mango growers in India, in various parts, they are not aware of such things. So the responsibility of ours, science center, farm science centers in India, we have KVK system in India, we call in English, the farm science centers, agricultural universities in different locations. The responsibility of these institutions also rises to create the awareness among the mind of the farmers so that they pay attention to these technical things and their commodity is in consistence so that it can be traded in various parts of the world so that the benefit accrues to them. At the same time, on part of the management options, so when the farmers are growing it in the event of occurrence of any disease or insect, they apply the pesticide or agrochemicals. They need to be told which compound is banned, which compound is not banned. What I'm trying to say is that the awareness on part of the each and every aspect of mango, as long as it is there on the trees, cultivation and retention of the fruits on the trees, these factors has to be born in the mind of the farmers. They need to be educated on a continuous basis. At the same time, the facilities for the quarantine treatments like hot water treatment and vapor heat treatment and irradiation are not easily available at each and every locations. So although it needs a huge amount of investment, but there is a government policy that the government gives some financial assistance those who want to develop this kind of facilities. But the question is, again, how we can reach to the farmers that such kind of facilities are available for you to avail of. And you know that almost 82% of the human resources are employed in this sector are unorganized. And they are very less educated. Therefore, it really assumes much more significance to provide them on a continuous basis the training and knowledge partnership. Lack of the adequate cold chain and warehousing facility in India. Of course, the central government is giving a lot of focus on this one. Wastage rate in case of mango is high. I'm really afraid that the large proportion of the mango growers in India, they are not aware about the maturity standards. Or even those farmers who are aware of the maturity standards, they don't follow in practice. So our responsibility is that we have to tell them that, see, this is how the maturity standards can boost the quality, and this can raise the shelf life and improve the marketability of the mango fruit, either in the local market or in the global market. At the same time, the traceability system for the mango, when variety of new compounds are coming in the market for containment of the diseases, fertilizers also, new formats of fertilizers are also coming in. So the traceability system, which is a must for the other side of the recipient side of the mango from India, that needs to be popularized. The knowledge about it, how this is going to be used, the quantum and way of applications, and they need to be told. These need to be told how, in what frequency, higher quantities, how harmful is for the mango, for the environment, and also for those who are going to consume this kind of product. So it really pains us when even sometimes the educated farmers also do the mistakes on these issues. So on a continuous basis, if we keep on training them, keep on making them aware from such points, I think we can motivate them for its benefit, and they will come for the good agricultural practices for mango production. You know, in India, whatever mango processing happens, the greatest chunk of the mango which is processed, there we have the very outdated or antiquated processing system, because they never thought that there is a need of the change in the old system. And for that, the government of India, through various agencies, they provide the financial assistance. And as much as 35 to 50% financial subsidy is there on these machines and tools to develop. But the responsibility lies on our shoulder also when we are reaching to the farmers to promote a variety or any package of practices in relation to the mango. I think we feel that they should also be told the complete package also. What are the government schemes, either by the local government or by the central government, and they can avail the benefit of these things for the benefit of processing. And they can update their machinery and tools which they're making use for the processing. You know, the most of the products are traditional in nature, and therefore innovations are required to diversify the product range. And only then the possibility of making the investment in scientific research and development of mango in India through the institutions, either by ICR institutions or by the other agencies, can happen in a way which I can say is a successful one. And I know the conference like this, which is a great source of inspiration, where you share the experience of various locations in the world, about the technology, management options, marketing avenues, how many success stories also. So when we come to this kind of platform, I think it becomes a great source of inspirations to many youngsters, young scientists, those I know, they have joined here on this platform. So I'd like to congratulate each one of you for having taken time out to take part in this conference and share your knowledge and wisdom for the benefit of those who need it, for value addition, for processing, for diversified products, and I'm sure for marketing also. I wish this conference for the great deliberations with the best and the brightest of mango in the world, and I hope many fruitful points will emerge here. And I'd request Niftem, particularly Dr. Sunil Parikh, to make a very unconventional recommendations out of this meeting, so that you at your own level also, and if you get a copy of that from our level also, we can get it pushed from the offices at the ministry level where such kind of decisions are taken, so that benefit accrues, policy push occurs, and once we converge together, I think we can make the mango farmers happy, uh, and we can also make the mango cultivation in India a very fruitful, very remunerative, and ecologically sustainable also. Thank you so much for giving me a chance to speak here. Sabhi ko namaskar.
Thank you, sir, for your encouraging words and overall scenario of the mango industry in India and how we can improve this, particularly for the processing and the export purpose. So we are really thankful from core of our heart, and we can see that at the late night you are in your office only. Now we are entering into the some typical post-harvest physiology and science of the mango. I invite Professor Jeffrey Brecht, who is also my good friend from the University of Florida, and he joined early in morning there. As all of we know about the Jeffrey Brecht, his successful post-harvest handling of mangoes requires. So Dr. Jeffrey Brecht is the professor of the horticultural post-harvest technology at the University of California, University of Florida there. Dr. Brecht received his BA in biology from Whittle College in 1979, which is my birth year, and PhD in plant physiology from the University of California, Davis in 1984. He has been of the faculty of the University of Florida since 1984, where he is currently a professor of post-harvest plant physiology. His research program involves studies of harvesting, handling, storage, transport, and the physiological and metabolic processes involved to the development, maturation, and senescence of horticultural crops. He also shares statewide post-harvest extension responsibilities and co-teaches a beginning graduate level course, Principles of Post-Harvest Horticulture. Dr. Brecht and his colleagues work closely with companies involved in the distribution and selling of perishable foods to conduct multidisciplinary research, and through his interactions with commodity associations, packers, shippers, distributors, importers, exporters, processors, and retailers. He extends information regarding advances in perishable food handling. Dr. Brecht has been involved in international post-harvest research and extension projects in Central and South America, Asia, and Africa also. He has authored over 500 technical publications, including 190 refereed journal papers. He was named a University of an honorary University of Florida Research Foundation professor in 2022, a fellow of the American Society of Horticultural Sciences in 2006, and is honorary member of the Florida State Horticulture Society in 2014. He is familiar with recommendations of the best practices and optimum conditions to use the storage and transport of fresh fruits and vegetables. He has recommended the best mango post-harvest handling practices, which was adopted by the National Mango Board of the US also, and we are also using as a recommendation here in the India. And so we are very fortunate that you are kindly give your talk on the post-harvest physiology, biology, of the mango crop. So now you can share your presentation from there only, or otherwise I can share from here. If you are able to share from there, it will be better. Please unmute. I have sent you the request. Brecht, please unmute yourself. Request has been sent to you. Then I unmute all.
I'm sorry about that. The system was telling me that I couldn't unmute myself. Maybe you should start my presentation for me.
So I should share. Okay.
Yes, please. I'm not familiar with WebEx, so it's probably easier for you to do it for me. So while we're waiting, let me say thanks to Dr. Parikh for inviting me to make this presentation. I have to admit that it feels a little odd to me to be someone from Florida being represented as a mango expert to an audience of mostly Indians, where you've known mangoes for such a long time. With the history here in Florida, the Hayden variety was only selected about 100 years ago in Florida. So it's a very recent history for us. So I'm going to be talking about mango post-harvest physiology.
Not coming for the sharing here also.
My colleague and friend, Dr. El-Hadi Yahia, is going to follow with a talk about post-harvest technology. So hopefully our two presentations will be complementary. We did share them with each other, so we have an idea of what the other is going to speak about. Dr. Yahia and I actually both know each other from graduate school at the University of California, Davis. So we've known each other for about 40 years. Here we go.
I've shared your presentation. Can you see these slides?
I can see the slides. There we go. Am I going to be able to advance the slides myself? Doesn't look like it.
The second slide on introduction. Yeah, I will move. You can.
Yeah. To start with, I'll say that my frame of reference is the international marketing of mangoes within the Americas, where the transport times over the ocean from South America to USA and Canada is on the order of 2 to 4 weeks. So we have to handle mangoes in such a way that they could be able to maintain their quality during those kind of shipping distances. So managing mango quality primarily involves control of ripening. So you're trying to do things that will slow the ripening of the fruit post-harvest so that they can be at the optimum stage for eating at the time that they reach the consumer. We're also trying to avoid physical damage and physiological disorders and control or avoid decay. And these are all factors that are related to the post-harvest physiology of the fruit. Next. It doesn't seem that I can advance the slides, so I think you have to do it for me. Oh, there we go. Okay. Sorry. So mangoes are mature climacteric fruit, and I'll explain what climacteric means. A physiologically mature mango can ripen normally the same way, either if it's on or off the tree. Of course, you get the best quality if the fruit are allowed to begin ripening, at least on the tree, but we can't afford to let them ripen fully in our system because a ripe mango can't successfully make it to the market in another country. Mangoes have low ethylene production, but they're very sensitive to ethylene effects. And ethylene, next slide, please. I thought I advanced it myself, but I guess I didn't. So climacteric fruit include other fruit like apple, avocado, banana, guava, papaya, passion fruit, peach. And this feature that they're able to ripen normally after harvest is what's used in the post-harvest handling of fruit like apple and avocado and banana, which are harvested at a mature but unripe stage and then either stored or transported. In the case of banana, they're transported around the world. The non-climacteric fruit, on the other hand, are fruit that have to ripen fully on the plant, and that includes things like citrus fruit and grapefruit are the two biggest examples. Yes, go next slide. And so this is a illustration of the pattern of respiration rate and ethylene production by these two types of fruit. And what you can see is that in the climacteric fruit, there's this upsurge in respiration and ethylene production that coincides with the ripening of the fruit. And the fruit are pretty much fully ripe at the peak of that climacteric respiration or CO2 production. And beyond that, they're simply senescing or aging and dying. The non-climacteric fruit don't go through that, that pattern. Next. So the respiration rate is tied to many metabolic processes within a cell. It produces ATP, which is a molecule that is used in many chemical reactions, including enzymatic reactions, to fuel the chemical reactions in the cell. So the respiration rate is actually a reflection of the demand of the cells of the fruit for this energy to fuel metabolic reactions. So the higher the metabolic rate, the higher the respiration rate is in response to that. That makes respiration rate an accurate indicator of the metabolic state of a cell. And it's a good indication of the potential duration of post-harvest life, because the more rapid the respiration rate, or especially the more rapid the change in respiration rate over time, the shorter the post-harvest life is going to be, because the plant cells are burning up their respiratory substrate to make that energy molecule ATP to fuel the metabolic reactions. Next. And so if you look at the different fruit that I gave as examples of climacteric and non-climacteric fruit, you can see that their respiration rate varies from very low to very high. And mango is sort of in the middle there with a moderate rate of respiration. Things like citrus fruit have lower respiration rate, and generally you see that things with lower respiration rate have a longer shelf life. And other things like passion fruit and strawberry, one is climacteric, the other is non-climacteric, but they both have very high respiration rate and a much shorter shelf life. So as the mango fruit develop, they're going through a growth phase, reaching full size, and as a harvest index, pickers look for that shape change in the fruit. They talk about the mango developing shoulders, so it becomes more fully rounded in a side view. And so when it's fully mature, but even before it starts to ripen, you can tell by the size of the shape. Tree ripe, in our terminology, actually refers to mangoes that have started ripening, not that they're fully ripe on the tree. So we go from a mature green fruit to a tree ripe fruit when it starts to ripen. Next. And so you can see that what we refer to as a mature mango is a mango that has started to ripen, as you can see here in the lower right, with the beginning of the development of the yellow carotenoid pigments in the interior of the fruit. Next. Mango is physiologically mature when the seed has fully developed, because obviously the biological purpose of the fruit is to procreate. The fruits reach full size. You get dry matter accumulation in the form of starch. And then we use these stages 1 through 5, and they're referred to as maturity index, but in fact, they're measuring the progression of ripening of the fruit. Next. So the ripening initiation coincides with the attainment of maturity. You get initiation of that climacteric ethylene production and respiration, change in color in the fruit, and the beginning of the conversion of the starch to soluble sugar. And the next slide will show those changes, how those changes coincide. So you see here in the upper figure, the ethylene production beginning to go up, and the increase in the carbon dioxide production, and how that coincides with a decline in starch and a coinciding increase in soluble sugars, shown at the bottom there, mostly being an increase in sucrose as the starch is broken down. And then those sugars become the respiratory substrate. In mangoes, mangoes are a very rich source of phytochemicals. There's a number of nutrients, of course, carbohydrates, the sugars that I've already been mentioning, also organic acids. which are also very important for the quality of the fruit. The balance between the sugar and acid is an important determinant of the flavor quality of the fruit. There's also some proteins and amino acids, there's lipids or fatty acids, there's minerals in the mangoes, but maybe more importantly, mangoes contain a large amount of bioactive compounds. There's many vitamins, A and C, vitamin D, E, K, B complex vitamins, and antioxidants particularly. So the pigments in mangoes, the carotenoids, actually have bioactive function as antioxidant compounds. There's also many phenolic compounds in mangoes. They're not so important as pigments, although there are pigments that are phenolic compounds. But we have flavonoids, xanthones, phenolic acids, all also acting as antioxidant compounds, which are beneficial in the physiology of the fruit, but also happily, they're also beneficial to our human physiology when we consume them. Next. Next slide, please. So these bioactive compounds, which are primarily those pigment classes of compounds, they have antioxidant activity. They provide immunomodulation or anti-inflammatory activity. They're anti-proliferative, which means that they counteract cancer in the body. They have anti-diabetic effects, so they counteract the effects of high blood sugar on the cells in our body, and they have anti-hypertensive effects. Hypertensive meaning high blood pressure. Next. So the vitamin content in mangoes is very significant, especially the content of vitamin A. So many of the carotenoid compounds act as pro-vitamin A compounds, meaning that in our body, they can be converted to vitamin A. And you can see that there's also significant amounts of vitamin C, B complex vitamins, folate, vitamin E, and vitamin K in mango. So mango is very important in our diet. Next. So carotenoids in particular, mangoes are a rich dietary source of carotenoids. These are the yellow to orange pigments that you find in the fruit. They act as provitamin A. And this is important because in many areas of the world, vitamin A deficiency is a critical problem, and it leads to a number of diseases in people. Vitamin A deficiency is the leading cause of preventable childhood blindness. It also this deficiency also diminishes our ability to fight infections, and it contributes to a range of maternal mortality and other poor outcomes in pregnancy and lactation among women. So consumption of mangoes can play a very important role in the health of us as humans. Next. So this is a figure. Actually, this comes from Dr. Yahia. I'll let him explain in detail if he feels moved to. We're actually preparing a paper that's being submitted, a review paper on mango health benefits. That's going to be submitted if he hasn't submitted it already. And this is a figure from that paper, which you can watch for. It'll be published soon, I hope, showing how these carotenoid and phenolic compounds entering the cell and counteracting the effect of reactive oxygen species. So that's the antioxidant effect of these chemicals that we get from consuming mango and other sources of antioxidant compounds like mango. And then that can overcome a number of other negative effects on our cellular metabolism. And also these compounds can affect the gene expression in terms of transcription, and in that way producing compounds that counteract some of these effects that I mentioned before, the immunomodulation and the anti-inflammatory and etc. Next. So I'm going to shift gears a little bit now, and with the rest of my talk, I'm going to go back to the mango physiology itself and talk about physiological disorders. So these are all disorders that can exhibit themselves during the post-harvest phase of the mango physiology. They can arise from pre-harvest conditions or from post-harvest conditions. And these pre-harvest conditions can cause the disorders where the symptoms don't appear until the post-harvest period. And so this can involve things like the production, location, seasonal environmental conditions, making the mangoes more prone or less prone to develop certain disorders, orchard conditions, including importantly nutritional programs or fertilizer programs for the tree, the fruit development stage at harvest, in other words, harvesting immature fruit, or harvesting over mature fruit. Either of those can increase certain physiological disorders. The post-harvest conditions rather that induce these kind of disorders include environmental factors like heat treatments. In our system, all of the fruit being exported to the United States from Mexico and South America are receiving a hot water treatment, which is a quarantine treatment against fruit flies so that we don't get these fruit flies introduced into the United States. And there's problems with that hot water treatment if it isn't applied properly, or if the fruit are immature, they can be injured by it and cause a physiological disorder. You also have storage temperatures and storage atmospheres that can cause physiological disorders. Yeah, go ahead to the next. So I'll start with sunburn. This is basically a physical injury from UV radiation from the sun. It can actually happen on the tree, but we more often see it when fruit are being transferred after harvest in an open bed truck and the sun is beating on the uppermost fruit. The temperature can easily increase by 20 degrees or more above the ambient air temperature. And also sometimes the mangoes will be parked outside a packing house and not shaded, and they can get this damage to the tissue. Next. Next, please. Yeah. Internal breakdown is sort of a collection of different post-harvest physiological disorders that have as their origin pre-harvest conditions. We see all of these in Florida mangoes, and most of the mangoes being grown in Mexico and South America to be shipped to the US are Florida origin, which, by the way, recent genetic investigation has shown that the Florida mango varieties are largely descendants of Indian varieties. Anyway, so they're classified as soft nose, as you see in the upper right, jelly seed in the middle, and stem end cavity to the lower right. So these all come from a similar source, which has to do with either calcium deficiency or excess nitrogen at an early stage in fruit development. Next. Sap burn is something that we can see post-harvest. The latex from the fruit can squirt out or drip from the cut stem end. It's nothing but a cosmetic effect. There's a burn on the skin of the fruit, but that effect makes the fruit unmarketable in our system. If you press forward, there's a picture of the squirt. Next, please. Yeah. So under certain conditions, under certain conditions, there can be quite a bit of hydrostatic pressure that leads to this latex actually squirting out some distance. So the fruit typically are harvested and then tipped upside down on racks in the field to allow that latex to stop dripping before the fruit are moved farther and taken to the packing house. Next. Chilling injury is a very important disorder for us because we're picking the fruit before they're fully ripe, which makes them more sensitive to low temperature. But low temperature is our primary technology, which I'm sure Dr. Yahia will talk more about, to slow down the ripening. So chilling injury is always a possibility and a potential problem. It's complicated in that there's a combination of the maturity of the fruit affecting the susceptibility, and not only the temperature itself causing the injury, but there's a time factor. So the fruit are actually tolerant of chilling temperatures if it's a short exposure, but the longer the exposure, the more severe the injury. This table is from a research project that was conducted for the National Mango Board here in the US, and it shows that there's also a cultivar factor involved in the chilling injury. Some mangoes are more sensitive to low temperature than others, as you can see here with Ataulfo, which is more recently being called honey, being more sensitive than the others, and Kit and Tommy Atkins being less sensitive to the low temperature. And it also shows that as they ripen, going through those 5 stages that I illustrate there in the upper right, they become less and less susceptible to chilling injury, meaning they can tolerate lower temperatures. Next. There's going to be a sequence here. You can just click 5 times, actually. The chilling injury symptoms come in a sequence. Okay, stop. There's loss of aroma initially, which is very important because you can get fruit that have been chilled and they show no visible symptoms, but they've lost their ability to create aroma compounds. And so the flavor is negatively compromised. And that's an important problem in our marketing system. After that, you get lenticel discoloration, which is sort of a general response to stress that mangoes show. Then you can get skin discoloration, sort of a grayish brown appearance, followed by vascular discoloration, and then a scald-like effect on the skin, and finally pitting, and one more internal discoloration of the flesh. One more click, please. Yeah, internal browning is usually the final symptom with the most severe chilling injury. Next. Then we also have heat injury. This is something that we see because of that hot water treatment that almost all of the mangoes being exported to the United States have to undergo. It can be a high temperature forced air treatment or vapor heat, which is actually rarely used. It's almost always hot water immersion. And this is 60 to 110 minutes. The mangoes are immersed underwater that is at about 46 degrees. So it's very high temperature. The fruit are underwater, and as they're warming, they're going through much higher respiration rate. But of course, there's no ability for air to be introduced because they're underwater. So eventually, it starts to damage the tissue. Next. And this hot water treatment, like the chilling injury treatment, is more severe the less mature the fruit are. So we see this as an indicator if the handlers are harvesting the fruit too early. And like the chilling injury, there's a sequence of symptoms that we see. First, lenticel discoloration, then cavitation, next one, which is pockets inside the fruit, vascular discoloration, and surface scald. So these are all symptoms of heat injury in mango. Next. Then we also can see atmosphere-related injuries, because I'm sure Dr. Yahia will mention modified atmosphere, or MA, and controlled atmosphere, or CA. This is a supplement to low temperature, so you get further slowing of the metabolic rate, further slowing of the ripening if you lower the oxygen and increase CO2. But if that's done improperly or by accident, then you can get injury to the fruit. The most common reason that we see these kind of injuries in mangoes in the US is because of a closed fresh air exchange in the marine containers. Next slide, please, or next picture. So that arrow is pointing to a fresh air exchange in a marine container. That's a adjustable opening to allow air from outside to mix with the air inside the container. It's done to typically avoid accumulation of ethylene and avoid accumulation of CO2 from respiration. But if mistakenly it's left completely closed, then you have the mangoes in a sealed container, and you can get injurious low oxygen and high CO2. Next. And then I'll finish up with a couple of other disorders where we don't exactly know the cause. The first is black flesh, or in Hispanic countries, it's referred to as Porte Negro, or black heart. And we did a 3-year project, again funded by the Mango Board, looking for what predisposes fruit to develop this disorder. We were able to show that it's a symptom of chilling injury, but we tried to see if we could either increase or decrease the incidence of the disorder by varying the calcium and nitrogen fertilization, as I mentioned in the internal breakdown disorders, but we never saw any effect from that. So the actual basal cause of this disorder, we still don't know, but it is a chilling injury, the symptom. So if you avoid chilling temperatures, you can still avoid the disorder. Next. And then finally, there's a disorder we see occasionally called black seed or pepita negra, which is basically a necrosis of the seed in the fruit. And it's presumed to be a calcium deficiency disorder, but I'm not aware of any research actually confirming that that's the cause of the disorder. Next, final slide. And that's it. I'm finished. Hopefully, we didn't go too far over because of the technical problem at the beginning. But I think probably we'll take questions at the end rather than now, I assume, right?
Thank you, Dr. Brecht, for your nice presentation, pictures, and overall scenario of the post-harvest physiology, and particularly the post-harvest physiological disorders, which are have the great importance and also are the major problem in the supply chain of the mangoes. And now I invite Professor Alhadi Yahya for the main talk of today's webinar. He is the person of the post-harvest handling of the mangoes. Dr. Alhadi Yahya is Emeritus Professor and Senior Scientist at the University of the Querétaro, Mexico, where he teaches, conducts research, and supervises graduate students and the global food industry on food security, post-harvest technology, food science and technology, and human nutrition. He published 20 books in 3 languages and more than 400 book chapters and scientific and technical articles on biology, technology, and handling of scientific and technical articles on biology, technology, and perishable horticultural crops. He acted as agro-industry officers at the Food and Agriculture Organization of the United Nations, where he collaborated on launching the global initiative on food loss and waste reduction, and developed national and regional agro-industry strategies, among other activities. He served as consultant to many organizations such as FAO, the World Bank, the Asian Development Bank, the World Food Logistics Organization, USAID, USDA, ICARDA, and many others. He is members of the Mexican Academy of Sciences, the New York Academy of Sciences, the Scientific Research Society, that is Sigma 11, the Scientific Advisory Council of the WFLO, and several other national and international organizations. He holds a BSc from University of Tripoli, Libya, then moved to the University of California for MSc and PhD from the Cornell University, Ithaca, New York, and postdoctoral training again at the University of California, Davis. He is just like as my mentor on the various aspects of the post-harvest technology, and always he gave us the guidance that how to conduct the research and how to write the papers. And even we published the 9 or the 10 papers in the author with the co-authorship of Professor Yahya from our lab. So with these words, I invite Professor Alhadi Yahya. Please share your slides, and you have the 40 to 45 minutes for your talk. Dr. Alhadi Yahya.
Thank you very much, Dr. Parikh, and for inviting me. And it is a pleasure and nice, very nice to be with you. If you could give me the, if you could author me to share my presentation. I think I'm not yet authorized. Could you please authorize me to share my presentation? Do you hear me well?
Yeah, I hear you. Just I send the request.
While waiting, let me just say that well, my presentation will try to follow, and of course it will be complementary to the excellent presentation just given by my great friend, Professor Brecht. And in fact, I have to repeat some of the things and basic information that he excellently presented, because as you could imagine, and I'm sure you know, there are basis for better handling of the fruit after harvest. Just wait here so that Dr. Parikh can give me the permission to share my presentation. Sorry, I'm still don't have the authorization to share.
Already gave you the privileges as a presenter and also make you the host.
Sharing is not active for me yet.
So first you leave the meeting and again join.
Oh, really? Okay. Sorry for that. Let me. So I just leave, just get out.
Yeah, leave and again join.
Okay. I'll do that. Let's hope you don't. I'm leaving the meeting.
Sent you the request for the unmute and also you are the presenter. Please unmute yourself.
But I still don't
You are
have. I
at the
still
bottom.
don't have.
There is the share.
Yes, but it is not active for me. I see it, I press it, but it's not active. I can't do it. Unfortunately, it looks like that WebEx is not a very common program used in this part of the world. It's still not active for me, Dr. Parikh. Everything else is active except the share button. Are you still with me?
Still, it is not there.
Maybe you should just start speaking, El Hadi.
I'm saying that I hope that you hear me first. The share button is not active for me. It's inactive.
See now.
You are okay. You are now the host. Yes, now I am the host. Okay. And hopefully, let's see if this one can do it. Boy, I'm still, no, it's not active.
Now see.
Yes, maybe, yes. I think right now, yes. Right now, yes. Yeah, it is active. So let's hope that it won't. Let me think. Point, okay. I have no idea.
It's a blank actually.
Yeah,
You can
it
share,
is.
but first you open your PPT.
It is open. Yes, it is open. Yeah,
Then
but I have it open.
share option is there, and after that you click on your PPT slides.
Yeah. That's what happened now. That's what I thought I did. Oh, good.
Then again you should unshare this.
I do what?
From the top, first you have to go unshare your slide.
Unshare.
Yeah. First go to unshare.
Where is the unshare? Why should I unshare?
Unshare is at the top. When you click on the top, then stop sharing.
You are, yeah. So?
Now stop sharing first.
It doesn't do anything. It doesn't allow me to do anything. You are sharing. It says that I'm sharing Microsoft. Can you see it now?
Yeah, yeah.
You see my presentation?
Yes, yes, yes. We can see your slides. Now
Thank
you can,
you. Thank God.
perfectly,
Thank you. Thank
perfectly.
you. Sorry for all that. Okay. It must be the age and a few other things. But thank you very much, first of all, and I'm terribly sorry for all this technical know-how or not know-how. Well, as I said, well, this presentation, I hope I can follow the excellent presentation done by Professor Brecht. Okay, let's start first. I hope that you've seen that I've changed the slides. It's very important.
Yeah.
Let's
Yes.
start by first seeing some of the very basic information that we need to know for a proper handling of mango after harvest. First of all, as Professor Brecht has indicated, mango is an excellent health fruit. It's especially with its very rich pigment content, especially the carotenoids part of the pigment, and especially its contribution and the contribution of these not only to vitamin A, and especially in the area where mango usually produced in the tropical area, some very poor areas where vitamin A deficiency is very pronounced, but also with its contribution as an antioxidant product, as also Dr. Brecht has indicated very well. Dr. Brecht also has indicated that the fruit is a climacteric fruit. We have to still keep remembering that and all what it means. He mentioned that it's very sensitive to chilling injury, something it's important to notice and always remember when to handle a mango fruit. It's a tropical fruit, and being tropical in tropical areas, meaning that it can be easily infested by many types of diseases and insects, especially fruit flies. So all of those are very important component that needs to be remembered in order for mango fruit to be handled adequately after harvest. As one of our speakers has indicated, and I'm sure you all know, especially in India and in Asia in particular, there are so many types of mangoes, hundreds, if not thousands of them, varieties and lines with very diverse characteristics. And I'm sure you know the characteristics there, maybe not as many here in the America, but extremely diverse characteristics in the sites of origins in Asia, and especially India. And these characteristics are very important also to know. They are very distinct characteristics, especially sensory characteristics, including shape, colors, flavors, and different types of mango are preferred, very much preferred in certain regions of the world, as it is in even inside one single country like India. Now, whatever the type of mango is, and whatever this diversity and whatever the preference of the consumer is in a certain region, specific quality characteristics of that very specific type of mango should be noted, should be preserved, and should be maintained. Both fruit visual quality, which is desired by certain consumers in a certain region, and also sensory, and of course, the phytochemical contents of that certain variety or certain type of mango. So it is very important to note, to remember, and to preserve whatever the type of mango and type of cultivar that is very specific to a specific region, to a specific type of consumers in a certain location. Form, the size, the external color, the internal color, the flavor, the size, the content, including whether fibers or pigments or other phytochemical contents, and of course, always the safety aspect of the fruits. These are the major important potential deterioration causes of mango fruit after harvest, which need also to always be remembered for careful handling to avoid them, or at least to reduce their negative effects to a minimum. Latex staining was mentioned, which is very important. Diseases is important in mango. Insects, especially fruit flies, which not only causing quantitative problem, but also a lot of logistical problem. And of course, being a perishable, being a climacteric fruits, the continuous ripening and deterioration processes, and the rough handling and mechanical injury, the loss of water and nutritional components that are lost with that water, and the low and high temperature injuries that was mentioned by Professor Brecht, and I'm sure all the speakers will do that. As a perishable, fresh fruits, water loss is very important. Water is readily lost, causing not only qualitative problems, but also quantitative losses and problems. Professor Brecht mentioned and explained very well the problem of latex or sap staining, which is also seen very much in India and everywhere, which not only causes major problems, major quantitative problems to the fruit, but also cause, as I'm sure you know, you've seen, you live, also cause problems to the workers also. The problem can somewhat easily be reduced by better handling in different ways. I think Professor Brecht, even though indirectly showed you when leaving short petioles on harvest, a very, very easy practice, which can easily reduce major part of the problems, and cut it again a little later, something very simple, but can reduce part of the problem or significant part of the problem. Harvest, the time of harvest, and the stage of fruit at harvest, and not harvesting either too early in the day or during or immediately after fog or rain, especially when humidity is very high, which is not sometimes is not done properly. Washing, a very, very simple practice, and especially using disinfectants as soon as possible after harvest, is some of the very simple practices, not exactly expensive practices, but very simple practices. If growers can be trained to use, then they can reduce some very important problems, including the latex of the sap problems. Post-harvest diseases are the most important causes of mango losses and waste quantitatively. Many are initiated in the field and then developed further after harvest. Some in the form, in fact, the most important ones are in the form of latent infection, such as the most important of all, the anthracnose, which is a major problem practically everywhere, especially in the growing regions with high humidity. There is always a need to avoidance and control measures and treatments. starting, of course, with the proper field practices and treatments, avoiding a reduction of rough handling and mechanical injury, proper cooling and temperature control, and of course, the use of other complementary treatments such as hot water or hot air, or using modified and controlled atmosphere that was mentioned earlier by Professor Brecht. Use of irradiation, which is becoming somewhat common, including in India, and also use of authorized chemicals whenever it is possible and authorized. Insect is another major important everywhere in the tropics, even in subtropics, especially in the tropics where mango is commonly grown. Mango is infected by several insects, but the most important ones, as I earlier mentioned, are the different types of fruit flies in different regions, which not only, as I mentioned, cause quantitative losses, but also create major logistical difficulties when many of them are quarantines, including some of the ones in India that create problems in restricting the export of Indian mango to some countries, including the US. Important control methods for these include the proper pre-harvest practices, for sure, and the use of authorized pesticides. Right? That's very important. But also the use of irradiated insects. That's a practice that I'm not sure if it is. I don't think I've seen it in India, something that can be done. It's very intensively done in some other countries, including Central and South American countries. And the use of legal quarantine treatments, which include, fortunately, the hot water and the hot air, which can somewhat easily be used and are effective if they are used properly, are effective in mango. The use of irradiation, which started to be used also in India, it's much more used in other countries. And maybe develop some type of modified or controlled atmosphere that we call insecticidal atmosphere, hopefully be developed in the near future. And some of the chemicals that are allowed or authorized in some regions. Professor Brecht, of course, explained very well the major problem of chilling injury in mango. It's a problem because, as he said, we need to use the cold chain, and mango is very sensitive to low temperature. So as you've seen in some of the tables that he indicated, some of the varieties are very sensitive to as high as almost 13, 14 degrees Celsius. So that can create some problems. Chilling injury, he also mentioned, it causes the fruit to lose not only quantitatively, but he also mentioned the qualitative deterioration that's caused by chilling injury, as the improper ripening, the losses of sensory quality, especially flavor and odor, the losses of important components such as vitamin C, for example, which easily lost by chilling injury. And chilling injury can favor the development of diseases or the advances of diseases. And so not only quantitative losses, but also qualitative losses. And the injury incidence depends on how low the temperature is, below 10 degrees Celsius. The lower the temperature, the higher the sensitivity, and how long the duration of that exposure to that low temperature. And the earlier the stage of fruit maturation, as also Dr. Brecht showed, the more intense is the injury incidence. And adequate avoidance include the use of optimum temperature. That is the most important thing, which is from 8 to 13 degrees Celsius, depending on the maturity or ripening stage. More ripe fruit can resist lower temperature. Also using high relative humidity, very important, not very common, unfortunately, in the real world with the producers and the people who transport, especially mango fruit. Relative humidity should be at least 85%. And if possible, whenever possible, especially during marine transport, the use of modified atmosphere with especially with higher levels of carbon dioxide, a little less than 10% carbon dioxide, of course, with very high relative humidity also. Maturity and harvesting indices, some of the earlier speakers mentioned it, something very simple but essential, very important. You need to start with that, otherwise you will not start properly. Maturity indices used commercially in the industry now are somewhat established for mango. Fortunately, there are not very many. They include the shape of the fruit mentioned by Professor Brecht, especially shoulders, the formation of the shoulders and cheeks. The external color, which is not the best one, but also the internal color, which is much, much better. There are a few others being investigated, and I know that for many decades in India, there have been a lot of research on some of the development of maturity index, but those are not used, not established, not developed to be used commercially yet. External color is not the best index to use. Unfortunately, some people depend very much on that. It's not the ideal one. Especially, it's not good to exactly indicate the earlier stages of maturation and ripening. It may serve in very few cultivars, not in many, especially for local, but not for far away marketing. Fruit shape, though, especially fullness of cheek and shoulders shape, is much, much better index for almost all mango cultivars and everywhere in every region. And internal color changes is the best index for all cultivars, although it is obviously a destructive index. And therefore, we usually use it as a conformity after using the shape of the fruit. It's easier to note the shape of the fruit. And then if there is a doubt, then one can confirm it with the internal color. The fullness of the cheeks of the fruit and the elevation of the shoulders above the stem attachment is commonly a characteristics of all mango fruit cultivar development, and it properly indicates the changes in maturation and ripening. So that means it's a very good index. It's not difficult to notice, and it is not difficult to train the farmers and the harvester to note it and use it. And then it can be established at least as the first index for maturation and ripening and harvest, depending on the purpose of for harvest. If the purpose is to sell for local markets or for processing, etc., then one can combine it with external color. Otherwise, internal color would be the ideal one. The skin color, external color, as obvious, especially from this picture, is not a good index at all in almost all the mango cultivars and for almost all the purposes of harvesting mangoes. And as you know, especially in India, different cultivars have different external colors to start with, and some cultivars do not even change the external color on maturation and ripening. In most of the cultivars that change color from green to yellow, This index may be used sometimes only for delayed harvest, such as for local markets and for processing, but it is better to always use it only as complement to other index. And internal color, though, is the excellent maturity and ripening index. It changes uniformly in all mango cultivars, no matter what their external colors are, and clearly indicates that it relates to proper changes in fruit maturation and ripening. However, as we mentioned, it is obviously a destructive index. And as I have mentioned, we always try to use it as a confirmative index, especially combined with changes in the shape of the fruit. So based on, okay, so based on these, and then commercial charts have been developed, and hopefully they should be developed in every region for every cultivar, for every type of mango, to indicate the different stages of maturation and ripening for the specific cultivar in that specific region, right? Usually, those usually are based on the internal color, but also complemented by other component, such as, for example, firmness or bricks, etc., or maybe some other important component for some other cultivars. Let's see, it doesn't give me, okay. So this slide, for example, shows the contrast. It's giving me here something that causing me some, oops. I'm having difficulties. It looks like that someone is controlling my presentation for some reason. You still hear me? Hello?
From the first slide only.
Yeah, but something happened. I cannot, here it is. It comes back. No, I don't know. Something is happening to my presentation, I think. I can't control my presentation from here.
Move your slides.
No, it doesn't. I can't. Something is happening. Here it is. Oh, something is happening. Yes. So okay. So this slide shows a contrast between two types of mangoes. The cultivar that do not, or the types of mango that do not clearly change external color in a uniform manner during maturation and ripening, such as the Kent here, or represented by the Kent, and another type of cultivar that represents the mangoes that changes from green to yellow, such as this cultivar Manila that was mentioned earlier. As you can see, the changes in external color then and Manila are not a good indication for early stages of ripening. It may be for later stages of ripening, but not for the earlier stages of ripening when we need to know the exact time of when to harvest. That for only for late stages, and that would be only probably for local marketing or for processing, but certainly not for faraway markets. However, internal color in either of the two types or two cultivars, or all mango for that sense, changes are always uniform, okay? and consistent and indicate the development of the maturation and ripening of the fruit. And that's why there are some messages here that keep I don't know. I'm yes. Okay. I'm sorry. I'm receiving some messages and it changed my presentations. Okay. So harvesting, which is obviously should be done based on the determining the ideal harvesting time using the proper harvesting index, what we've mentioned. That is very, very essential. Harvesting should be done using proper way, with very, very simple, easy practices that need to be used to reduce the minimum possible injuries to the fruit and also to avoid latex flow. It should be done in the proper time. It preferably be early in the day or late when the temperature is not high, depending on the region, but not too early during fog, not during or immediately after rain. Some very, very simple practices that can be easily shown and train the farmers and the harvesters to do. Fruit should be collected properly using proper harvesting and collection bags, which is not commonly done in many regions. It should be accumulated in proper boxes, whatever the proper boxes are for that specific region. And it all depending on the type of operation, how big, how small the operation is. And of course, it depends on the expected purpose or use of the fruit and the after harvest, and the distance to the market and the type of markets, etc. Fruit should be protected while waiting on the field, something very simple, at least in the shade and preferably covered, and should be transported as soon as possible to where it needs to be transported, either the packing station or the market, etc. And all harvesting tools should be disinfected very regularly. Otherwise, they are the big sources of infections for mangoes later on. Here, during harvest is where most of the problems of mango starts after harvest. It is when the fruit are harvested very inadequately, which is very common in many regions of the world. It's when mango is dropped in the ground, unfortunately common. I hope it is less common, with major injuries. Most of the injuries happen in the fruit right here at this stage. It is here when a mango is collected from the ground with major possible infections. I hope it is not done anymore or not done as often. And it is here when mango is not protected while waiting for a long time in the field, sometimes under the sun. Unfortunately, also somewhat common in many regions in the world. Mango trees, as you know, are very tall, especially in India and the original areas. And harvesters always need proper harvesting tools and should never harvest mango by hitting and dropping. This practice should be illegal, should be stopped forever. Dropped mango is usually a lost mango. That's for sure, although it may not look like it on collection. In fact, it will never look like it on collection, but dropped mango should be considered as a lost mango. There are different, very easy and very cheap ways to develop proper means that do not have to be sophisticated at all that do not have to be expensive at all to collect mango properly. And this is a very important first initial step to handle mango fruit properly after harvest. Mango should be packed properly. It should be preferably packed in a controlled packing location. It doesn't matter how that location look like. It does not have to be big. It does not have to be sophisticated. It does not have to be expensive, but it should be controlled. It does not have to be as sophisticated as it looks here, but should be clean. It should be properly managed, and packing off the fruit is very essential for preserving its quality and for prolonging its life. Okay, so not harvesting properly and not packing properly is the initial of losing your crop after harvest. There is no universal packing site or packing location or packing house or packing design. And these usually differ based on and many factors, based on the investment, based on the quantity of the fruits handled, based on the treatments that one would like to apply for the mango, based on the type of market, how far it is, etc. There are different designs, many designs, in fact, and the importance here is only that the site should be clean, should be properly managed, where the fruit is handled with care, with minimum injury, treated with the needed treatments, with the very basic treatments wherever they are, depending on the purpose of the packing, and cooled as soon as possible. I'm not saying refrigerated, but at least cooled with any means, even by using shade or water, and either transported as soon as possible or maintained in an adequate cooled environment. Different operations are usually practiced in a packing site. Especially very important are washing and disinfection. Washing and disinfection. I repeat, washing and disinfection, both. Whenever washing is used, disinfection is also important. Treatments for disease and insect control, such as the use of heat in different forms, either in water, on air, etc. And of course, packaging and pre-cooling if possible. Washing is essential, is very important for all the advantages that causes to the fruit. It's also important to disinfect the fruit while washing it. Here, it's important because it cools the fruit, it reduces the temperature at least slightly. It also eliminates at least part of the latex or the sap, which is a very important advantage. Water should be clean and should be changed regularly, and the disinfectant, such as chlorine, which is the most available and most easily used, should be checked regularly to ensure activity, especially when the water becomes dirty. Mango fruit has the excellent advantage, has the great advantage of resisting heat, much more than many of the other fruits. And therefore, hot water and hot air, fortunately, commonly used for mango to control diseases, including the most important one, the latent infection of anthracnose. Hot water is excellent for controlling even anthracnose. And heat also is authorized as a legal quarantine treatment for some pests, Professor Brecht mentioned that there are different authorized legal treatments for that. The most common one is also indicated by Professor Brecht is this hot water treatment, which was developed almost 40 years ago in Mexico at temperature of 46.1 degrees Celsius for 65 minutes or more, depending on the weight and the type of cultivar and weight of the fruit. This is a very excellent treatment when it is used effectively. Okay? Otherwise, it can cause problem and cause injury. For diseases control, we usually use higher temperature and shorter duration treatments compared to when we use it for insect control. For insect control, we usually use lower temperature, slightly lower temperature, and longer durations. And there are many different designs used for these treatments, the hot water treatments or the air treatments. And doesn't matter what design is, as long as they comply with the temperature and the duration authorized, especially when it is a legal treatment. In all cases, there is a need for pre-cooling treatment immediately after the hot water treatment. Whenever the heat treatment, whether hot water or hot air treatment is used, hydrocooling is needed immediately after that. And this part, if the treatment is a legal treatment, is a quarantine treatment, then this part, the hydrocooling, is also regulated by the phytosanitary authorization with regard to minimum temperature and also with regard to maximum duration. The different legal treatment also have been developed, in fact, have been developed for a much longer time, more than 70, 80 years ago, based on hot air treatments. There are some already registered as a legal treatments. Some have already been used in India. It looks like that the hot water treatments universally used did not work or does not work properly in some of the pests that prevail in India. Again, there is a need here for cooling treatment immediately after a hot air treatment in case that it is used. And again, this cooling treatment also is regulated by the phytosanitary authorization in case that the heat treatment used is used as a legal treatment. Although mango is, as I said, relatively resistant, fortunately, relatively resistant to heat, much more resistant than most other fruits, but excessive temperature, higher than what the mango can resist, and excessive duration can cause a major problem, as Professor Brecht has explained properly. And that is why cooling immediately after heat I emphasize, is very important. And I sure would like to also re-emphasize that if heat treatment, whether it is hot water or hot air treatment, is not a legal quarantine treatment, then you can use the temperature that you like and the duration that you like. But if the treatment is a legal quarantine treatment, then the cooling treatment immediately after the heat treatment should comply with the phytosanitary requirements of that. Irradiation is becoming somewhat common in the world. In fact, it has been common for many years to irradiate food. and the irradiation is a safe treatment. It is authorized in many countries, in almost all the countries, to irradiate different types of foods for different purposes. And it became somewhat common to be used as a quarantine pest control methods in some countries in the last few years, as about 2 decades ago. It is used, and also the consumption of irradiated food, including irradiated mango, is authorized in practically almost all over the world. The initial investment, as I heard one of the speakers has mentioned, of course, it's very, very high. It's very, very costly, but the service cost is extremely cheap. It is the cheapest in service cost. That is why irradiation plants is usually installed by big companies and given the service, because the service is somewhat cheap. In fact, there is already since few years ago an irradiated facility right there in Mumbai that irradiates mango, especially to be exported to the US. The irradiation source most commonly used is gamma radiation, although other sources such as accelerated electrons and X-ray are also being used. That's why the irradiation application is increasing. The authorized doses for food irradiation is up to 1 kilogray, that is 1,000 gray, and the doses or doses above 1 kilogray cause injuries to almost all fruits and vegetables. Okay, and the doses need to kill insects are usually high, at least 500 grays or more. So we are talking about doses that can cause injury to the fruits, so those that can kill insects. But about 2 decades ago, there has been an agreement, and a somewhat international agreement, where for quarantine purposes, there is no need to kill the insect, but it is enough to sterilize the insects. And you only need less than 0.3 kilogray to sterilize the insect. So that doses has been established lately as a quarantine legal treatment, meaning that you do not need to apply very high doses to kill the insect, but it is enough to apply lower doses, less than 0.3 kilogray or 300 grays to sterilize the insect. And that's why that treatment is being accepted and being used commercially, including being used in India for mango exported to countries that do not allow certain types of quarantined insects. Packing is done, or packaging is done manually everywhere in the world, in India and Mexico and the US and everywhere. It should be done very gently. That's why women are the best in doing this. I hope that you introduce more women than men. I know that more men are being doing it in India, and that is not the most correct way to do it. Women are much more gentle with the fruit, and they are the one who do it best. And that's why you probably, I'm showing here a proof in one of the lecture. You can tell that when I try to get into a packing house and start packaging fruits, one of the lady got very mad at me and wanted to kick me out. Because usually men are not good for packaging all type of fruits and vegetables. Women are the best, so please start introducing women to package fruit, because I know I've seen only men doing this practice, and they usually do it in a very inadequate manner. It should be done packaging should be done in a very comfortable place for workers. It should be a clean place. It should be an organized place. It's better done on table rather than being done on the ground. It should be supervised by people who are familiar with the process and should never, ever overfill the packages, which is very, very common, unfortunately, in India, as it is, as I've seen it very, very, very much. There are too many types of packages, which is very common for all fruits and vegetables. Too many types, too many sizes, too many colors, too many shapes, too many designs, etc., etc. There is absolutely no way to standardize the type of packages for any types of fruits and vegetables. It hasn't been possible at all, but it doesn't matter. But when selecting and choosing the right package, here, for example, in mango, for any other fruit, it is important to make sure that the package protects the fruit, doesn't injure the fruit. It contains the fruit. That means the size and especially the weight is enough for a person to carry it adequately without dropping it. To promote cooling, especially by these vents and opening, very important. Easy to handle by the workers, so fruits will not be dropped several times, as unfortunately sometimes happen. And very important to promote and sell the fruit. And as it is everywhere, carton packages is used all over the world. They are the most common, but they should not be used many, many, many times, as it is common in several regions. In fact, it's preferable if it is possible to only be used once. Maintaining the cold chain is the most essential practice to preserve fruits and vegetables in general, including mango. And the cold chain starts with pre-cooling. That is the first step to have a good cold chain. Pre-cooling is the fast elimination of field heat, as you know, and commonly done immediately after, in the case of mango, usually done immediately after packaging. It is even more essential. It must be done if heat treatment, either hot water or hot air is used. In that case, you must use forced air cooling immediately after. And the hydrocooling is not very much recommended as a pre-cooling or as fast cooling method. Of course, it's important because it eliminates some field heat. It is recommended, as I mentioned, to wash and therefore eliminate some of the heat, but most recommended to reduce the temperature after hot water treatments. But forced air cooling, again, I repeat, is the most recommended to finally eliminate all the field heat of the mango. Again, I'm having difficulties. I don't know. Things are popping in my presentation and do not allow me to control my presentation. So I'm stuck here. I cannot do anything from my presentation. Whoever is controlling my presentation, please give me the control. I can't control my presentation. I cannot do anything. Do you hear me?
If someone is interfering or someone is hacked, I don't know.
I don't know. Whoever is, please let me. Okay. We only have very, very few presentations left. I can't. There is nothing I can do. I'm sorry, I cannot control my presentation.
If someone is interfering, please
Here,
make
yeah.
present.
Yeah, he listened to us. Thank you for allowing us. Okay, so transport. This is another important thing, especially in Mexico. I mean, in India. Transport is very, very important. It's very common. Is either from the field to the packing house, or the packing site, or to the different domestic or external markets, etc. And it is where some of the major problems occur, and some of the losses, major losses, occur in mango. Mango is still transported by all means of transport, by road, by river, by sea, by ocean, by air, etc., in India and everywhere else. And non-refrigerated transport is still very common in almost all over the world, also, not only in India, but especially in India. And many factors need to be considered, especially during when non-refrigerated transport is used, including, of course, temperature, air circulation, relative humidity, atmosphere composition, condition of the transport container or the transport vehicles, the condition of the roads, etc. Many factors. There are a lot of training, incredible, intensive amount of training still need to be done with the transporters, especially in developing countries, including India and other countries. Non-refrigerated transport is still very, very, very much used, not only in India and all over, even in the United States and Mexico, but especially in India, in road and in river transport. Air transport is always non-refrigerated all over the world. So it is fine to use non-refrigerated transport when it is necessary, when it is needed, but with some very careful conditions. The container or vehicle should be covered to protect against environmental conditions. That's very easy. That's very important. To cover from heat, to cover from rain, etc. And it should be clean. The fruit should be loaded properly to avoid movement during transport, which is very, very common. The vehicle should be in proper conditions, and one should always use the adequate roads or the better roads conditions. Obviously the refrigerated transport is much better when it can be used. It's the most preferred for road and for marine transport, especially for long distances. And containers and vehicles need to be clean. It needs to be pre-cooled before loading the pre-cooled product, meaning that the container should be pre-cooled and the product should be pre-cooled. The mango should be pre-cooled before start loading. Loading should be done properly to avoid movement, again, the same way, and to ensure the proper circulation of cold air. It's not enough that the temperature is low, but also the cold air circulation should be proper, so that low temperature should be uniform in all the container or the vehicle. And the temperature and relative humidity, both of them, should be properly controlled and properly maintained. The temperature measuring and control devices should be allocated in the right places in the container. And for road transport, we always, the same way, one should always follow better road condition. It does not matter how nice the transport vehicle looks like all over the world, in India and Mexico, in the state and everywhere. Drivers everywhere always make sure that their vehicles look beautiful from the outside because they are practically their homes. But unfortunately, most of the time they look beautiful from the outside, but they all look terrible from the inside. The most important thing is to make sure that the vehicle is proper from the inside, meaning clean, functional, especially with regard to controlled conditions. And as important is to make sure that cold air circulation, the air is circulated adequately. There are basically two types of air circulation systems that one always need to know during transport, in transport containers and vehicles. The above horizontal system that dominate in the road transport vehicles and the lower vertical system that dominate in the marine transport containers. It's important to always know what air circulation system is being used. Knowing that is very essential, and it's based on that one should use what proper package, what design of package, and the proper pallet formation accordingly. The load of the fruit also need to be done based on what system of air circulation. All that to make sure that cold air circulation is proper, that cold air is properly circulated, something that always is missing from the mind of many people who deal with the transport of fruits and vegetables. Modified and controlled atmosphere mentioned by Professor Brecht are very commonly used, especially during marine transport, not during road transport. There is no need to use them during road transport. In fact, in most of the cases, it is impossible to use them during road transport. As I'm sure you know, modified atmosphere means that we use atmosphere with a gas composition, especially oxygen and carbon dioxide, different from the normal air, which, and when we do that, we reduce fruit deterioration, we can reduce fruit chilling injury sensitivity, and we may even reduce the problem of diseases and therefore prolong the life of the fruit and preserve its quality. So it's important to use proper modified and controlled atmosphere. Controlled atmosphere is the same, but it is when we used oxygen and carbon dioxide precisely controlled all the time. And modified and controlled atmosphere are very, very, very beneficial, but only when they are used properly, especially by using proper oxygen levels and proper carbon dioxide levels, which is unfortunately not always being done in most of the time. If the oxygen level gets lower than what the fruit can tolerate, or the carbon dioxide level gets higher than what the fruit can tolerate, there will be problems. There will be injuries, and the fruit may even be fermented. Unfortunately, it is also common that modified atmosphere is always being sold as controlled atmosphere, so that they charge higher. But if one needs to use modified and controlled atmosphere during marine shipping from India to Europe, for example, to the US, it is important to know what system is being used, whether it is really modified or really controlled, and what levels of oxygen, what level of carbon dioxide are being used. And it's important to always know how is it that they are controlling it. because there are different systems being used in the industry. Professor Brecht also indicated, and this is some of the latest changes in the mango industry. Mango is being lately ripened artificially more often, and it is usually done when the fruit arrives to the market in order to offer the consumer uniform ripening fruit. As Professor Brecht has indicated, ethylene, which can be used either as gas or better, much better as generators, is used, and it's usually used in a concentration of about 100 parts per million, a maximum 200 parts per million. We always use a temperature of about 14 to 25 degrees Celsius for about 12 to 48 hours, all depending on the speed of ripening that we desire. And relative humidity always need to be high, at least 90%, and carbon dioxide should always be low, should always be maintained less than 1%. And thank you very much. We made it with all the high technology that doesn't seem that I'm very capable of handling. I apologize for that, and I thank you again, Dr. Parikh, and for your invitation, and thank you all for your very kind attention.
Thank you, Dr. Yahya. You have given all the protocols which we have to be followed for the maintenance and in the post-harvest management and the supply chain systems, and where we are lacking, that we can analyze ourselves. We are running short of time, so I don't take any question at this time, but participants can post their questions in the chat box, and then at the end we will take the questions, some of the questions. Please unshare your slides now.
Okay.
Stop the sharing. And our next speaker is Professor Hugo Sergio Garcia. Hugo Sergio Garcia obtained the BSc degree in Chemical Engineering from Veracruz University with honors, and he holds a MSc degree and PhD in Food Science, both from the University of Wisconsin Medicine. He is a full professor since 1980 at the Veracruz Institute of Technology and a visiting professor at the University of Wisconsin Medicine. The summers of 1992 to 2010 and in CSIC or UAM in Spain to date. He is an emeritus researcher in the National System for Researchers in Mexico. Professor Garcia has published 252 indexed papers and accumulated more than 10,000 citations with H index of more than 50. He has 2 books, 30 book chapters, 1 patent granted, and 3 more have been submitted. He has graduated 42 PhD and 90 MSc students. He was granted the National Award in Food Technology in 1996 for his work on mango hot water treatment, and served as chairman in 2002 to 2004. The Mexican Academy of Sciences elected Dr. Garcia as a regular member since 1999 and elected as chairman of Mexican Association of Food Scientists in 2015 to 2017. His international collaborations include works with colleagues from the Volcani Center, Israel, then Oviedo University, the University of Wisconsin Medicine, several institutes of CSIC, and the Autonomous University of Madrid in Spain, Korea University, and Bologna University, Italy. Professor Garcia's research interests include lipid biotechnology, nanoemulsions as carriers for bioactive compounds, probiotic bacteria, cholesterol oxides, antioxidants in colored produce, and post-harvest handling of tropical fruits. So he is the authority in the processing and the food technology. Throughout the world, he has worked in collaboration with the various universities. And now I invite Professor Hugo Garcia for his presentation. We are already running short of time, so we are the paucity of the time, but you can conclude your talk in next 20 minutes, I think. Just I unmute you.
Okay. Oh, now I'm in control, I guess. I'd like to immensely thank Dr. Parikh for this invitation to speak in front of you, mango lovers and mango experts. Been working with mango since about 30 years, more or less, intermittently. I also want to thank my good friend El Hadi Yahya, who gave a brilliant presentation with his also his friend Dr. Brecht. They're very enlightening, and it will help me to shorten my presentation because they already covered some of the aspects I was planning to talk about. I will keep my talk short. So the problem is that I still cannot share my presentation, even if I'm the co-host. It wouldn't allow me. Can you help me, Doctor?
Then I make you the presenter actually. Can you now
okay. Okay. Are we okay now?
Yeah, we can see your slides.
Okay. Now it's okay. Okay, this time it went smoothly, not with my good friend El Hadi, who had some technical difficulties. Okay, I'd love to start talking to you about the mango processing. You know, the last step before you take the mango to your plate or your mouth, there comes processing. Not all of the mango we consume are in the form of fresh fruit, the one we just get from the tree, let it ripe, and then peel and eat. There are plenty, as you will see, plenty of mango products that come out and emerge from different technologies, some very old and some pretty innovative. And I'd like to balance a little bit my presentation in terms of old classical technologies and a couple of new ones that I would like to discuss with you. Now, oh gosh, it's not allowed. Okay, there we go. Let me tell you first about the traditional technologies. We all know, we're very aware of the preserved and canned mango in several different ways. As we can see the pictures here, we have dry mangoes, mango chunks. These bags are basically come from for freezer. And we have canned mango, probably the oldest technology. You all know the origin of this canning technology. But then we have other products. We have preserves, we have jams and jellies. Jams and jellies are usually made with mango pulp or puree, which has been added with a pectin and citric acid to prepare it as a mango jam. There are derivations which are very much in the taste of Asian and Indian consumers, like a mango pickle, but mostly mango chutney. Chutney for the Westerns like me is an acquired taste, but once you get it, you really enjoy mango chutney because it's got the tanginess and the hotness that we are very used to. So that's a product that you don't see very often in this part of the world, in America. But I'm sure if it ever gets, if it reaches, we're gonna love it because we have hot pepper, chili peppers to basically everything. So we have dried slices, we have frozen. Frozen mangoes are available in most of the large stores that have freezing facilities. We have a jellified product. We have one that's very popular here. We call Ate, to which we basically make a solid product out of puree, and it's very popular. Not only with mango, but some other fruits which are also very popular. Nectars and juices are extremely they're very good selling products that come from the mango juice industry. These nectars and juices are usually blended with other juices, with honey, with starches and some other components to prepare a more viscous, more consistent fluid that's very appealing for certain ages. So these products have been in the market for years. Sauces, mango sauces, they're in everyday's kitchen in many countries. Those sauces that you make with blending mango pulp with some other ingredients, sometimes with hot peppers, or sometimes with just spices or tomatoes or any other vegetables. They're everywhere in the world. We have also powdered products. The powdered product is also quite old, over 40, 50 years maybe, or older. And it's probably one of the simplest ways to produce a mango product. We will talk about one of the latest technologies that have been around only for a few years, and that makes a nice turn into this drying processes. This is from a nice book that I came across with that summarizes most of the processes that you find in many countries involving mango fruit. There are two major ways to process mango. First, on the right, we have mature mangoes, which are not ripened, but just mature. And this is basically following the criterion that was very well described by Professor Yahya in the previous lecture. The mature, which means basically green mangoes, but mature, are washed, peeled, then sliced and pulping, and then we prepare pickled slices. We can prepare powder or chutney. Chutney is not prepared usually with fully ripe mango, but you can see, and we will not we shouldn't get into the details of all the processes, but basically these products have been around and they will stay there. I hope they will conquer more markets like the one in Mexico here. But then we also have the ripe mango industry that share basic steps of washing, slicing, peeling, and pulping. When you slice and pulp, you can derive to several types of products. We will talk a little later about fresh cut mango slices. We all know the canned slices of mango, very popular. And we have also dehydrated slices of mango, which are a very popular snack all over the world. Almost all the varieties in the world have been processed into slices, packed in plastic bags, mostly PVC or high density polyethylene, something that gets really transparent, and they're very popular. Canned pulp and juice, although it's badly written in there, sorry, it's not my fault. I just copy it. These products are used as a startup ingredient to formulate a number of other products. As you can see, you can adjust the bricks, the degrees bricks, and you can put acids, organic acids. You can thermal process, you can fill it, and then finally you can starch, pull, and follow all sorts of industrial steps. And as you see, the mango industry is pretty wide. The products are very quite varied, and there's mango for every taste. Some of the somewhat, I wouldn't say fully, but somewhat innovative processing technologies involve this. High pressure processing that was intended mostly for, in the case of mango, to process mango puree instead of HTST, the pasteurization or sterilization. High pressure processing, which is produced by either a piston or a chamber, is applied to the mango juice or pulp to very elevated pressures, up to 600 megapascals. And from that, you can either concentrate or you can pack and sell for further processing. We have also seen some applications in mango for pulsed electric fields. These basically are in the range of 10 to 80 kilovolts per centimeter. It appears that the pulsed electric fields are able to disrupt the microbial membranes of contaminating flora of the mango, and this is a very good disinfestation and sterilization of mango pulp and fruit. We have also ultraviolet radiation. You know, a few years ago, the UV radiation, which ranges from 100 to 400 nanometers, was split into three ranges: UVA 350 to 40, UVB 280 to 350, or UVC, ultraviolet C, that goes from 100 to 280 nanometers. The range that we use, or that's being used by industry to treat mango, is the UVC. That can be done either to treat the surface of the whole fruit and get rid of that plague that Professor Yahia told us, call it the Trichomonas poroides, that we know as an anthracnose. We can basically clean up and sanitize the surface of the mango using this kind of radiation, but we can also produce thin films of juice or pulp, very thin, because this radiation doesn't have very high power of penetration, and then we can basically sterilize or almost sterilize the pulp only by UV light. That's being used in the world in some countries. There's also the ultrasound treatment. Ultrasound is also able to disrupt the microbial cells, and it's used in this range of 20 to 100 kilohertz. It's been used, although not as widely as it should, because it's been proven that these treatments that I've described so far do not alter a composition, bioactives, or any other sensory traits of the mango. Now, I will probably skip irradiation because Professor Yahia spent some time on it, and he showed us pictures of countries that are using this technology. probably in the range of 0.5 to 1.5 kilogram. So the technology is there and it's being used. There is something new for most of us that refers to cold atmospheric plasma processing. Plasma is a mixture of free radicals, electrons, and electricity in general that's applied to the fruit or to the derived products as pulp or juice. Usually 16 kilovolts at an excitation of 30 kilohertz are employed to stabilize microbiologically and enzymatically most of the times the mango. One treatment it's quietly being introduced and it's working so far is the ozone pretreatment to increase shelf life. Ozone has been employed in many in the packing houses of many fruits and vegetables to sanitize. So it's also being used on mango. We just don't hear too much about it. We have been interested in heat disinfestation of fresh mango fruit. Why we will do that? I would not like to elaborate more on the material and all the excellent explanation that Professor Jahia provided us just a few minutes ago. But I want to point out that we want to basically attack two of the main problems. First, anthracnose on the left, that fungus that is really a plague here in my country. But also the second plague is the fruit fly infestation, like the one we showed here, which is not appealing at all. But we find this far too often. And there are basically three types of treatments. I'm not going to get into those details, only to mention that hot water immersion treatment is the most widely used in Mexico, basically for exports of mango and mostly to the US. The regulatory issues in here are very clear, and most of the Mexican packing companies that want to export will have to comply. Unfortunately, the rest of the mango that's used for internal consumption in my country does not have this treatment. It's basically designed for export. A winner, we do have a winner. Fresh cut mango products and packets are like those here. Chunks, slices have invaded the market in many countries, and they seem to work quite well. But in order to get to this point, scientists have to figure out how to counteract the trauma, if I can say that, or the injury caused by the cut to the tissues. Once the mango tissues are mechanically cut, this puts an extreme stress to the fruit. And then measures have to be taken to prevent rapid deterioration of the chunks and the slices that, as you see here, they have to be used in dips. They have to be applied covers, coatings, and sometimes antimicrobials. They have resorted to the use of natural antimicrobials to keep it organic, as you see here. The process, the overall process to obtain the fresh cut mango is displayed here on the right, and it's very obvious. But the magic, the technology, the science behind this is the use of these additives. Even though we refer this product as a minimally processed mango, well, yeah, it's somewhat processed and it contains some additives that you can regard as natural, but they're still additives. Otherwise, these slices or chunks will not last more than 1 or 2 days. When you use the additives, then you can shoot for 10 to 15 days on the shelf, and then you can take it home. In addition to the additives, most of the times we use control atmosphere of inside the package. As you can see, there's no room to breathe in here. That's because there's a control atmosphere injected with low oxygen, a little higher CO2 to keep the tissue respiration to a minimum without getting it into the anaerobic respiration. One example that of what we do here is when we add citric acid, we basically, this is not thermally treated. With citric acid, we basically prevent browning and keep the integrity of the chunks better. Sometimes we add citric acid with coatings, like in this case, as we see here, the cassava starch coating with glycerol, that even though it doesn't sound very organic, it's perfectly food safe, food grade. Sometimes, in order to keep the integrity, the physical integrity of the pieces, we use alginate coating. So we dip in alginate and then in a calcium solution, so we form like a film of calcium alginate to keep it firm and in place. This has to be very properly formulated in order to maintain a natural bite and texture, so it will be appealing to the consumer. And then, as you see, the respiration rate drops significantly when we use all these additives. In terms of nutrients, contrarily of those who are against technology, if we follow nutrients, you can see that most of the nutrients here are retained. In fresh cut mango that was stored, as it says there, for 10 days. So this is a winner, and if done properly, it will assure a good share of the market and a good business opportunity. A few years ago, like 15 years ago, we were interested in high hydrostatic pressure, but as a way to as a disinfestation treatment. In this case, I'll show you the work we did in the west coast of Mexico with Ataulfo mangoes. The problem we had, as you see, is these cavities, as they were described earlier by Professor Heck and Professor Yahia, and they come from the stress. Even though the Ataulfo mangoes, after being exposed to high hydrostatic pressure, showed an external appearance, they were edible. We had some lenticels darkening, which is almost unavoidable, but they went okay. We then wanted to work with the Manila variety. For this, we applied the same equipment, and we were able to inactivate all the larvae that we introduced artificially in this larvae production facility or sterile fruit fly production facility. They allowed us to use their equipment, and we found that our Manila mangoes, after being exposed to several minutes at 200 megapascals, developed this appearance when they were right after processing. And then when we allow to ripen, the control mangoes are here up in the upper side of the photograph. And unfortunately, the Manila mangoes, since they don't have the strong structure as other varieties. We basically had a poor appearance, and as you see, this is the pulp of a processed mango. It doesn't look like a natural one, but like a jelly, more or less. So it's just as Professor Yahia was describing, not even packing or processing cannot be the same for all varieties. Hydrothermal processing, even if it worked partly in Ataulfo mango, which is a Mexican variety, it did not work for one of the most popular varieties in Mexico, which is the Manila mango. That I must say, it's a descendant from the original Carabao mangoes brought from the Philippines in the 17th century. I then would like to call your attention to this process. Flash détente, as they call it in French, because it was developed by French. We know it in English as flash vacuum expansion, is a process by which you subject the mango, the whole mango, to atmospheric pressure. You steam it up to a temperature of 60 to 90 degrees centigrade. And then following this graph, you pass it to a vacuum, a very high vacuum, and then you go from the liquid to gas in an explosive way. They basically, that's why they call it flash. It's basically an explosion, because what happens here is, here's a mango cell here. No, it's not a mango cell. It was developed for grapes, to extract grape juice. And then since fruits in general have very large vacuoles, and these vacuoles are made out of mostly water, once you expose the cells to the high temperature and then you change to a high vacuum, the volume of the water inside the vacuole expands 1,000 times, which is really a fast process, being so fast that the cells cannot adapt, will never adapt, and then explode. And then they release their content. And as I hear Professor Poga in 1988 established the first patent, and after that he came up with a number of patents. And we in my institute, a group at my institute collaborates with the French to, they even built a facility, the equipment in Veracruz, right here. It consists of basically a heating chamber, which in this case is only 2.7 liter, and it's held at atmospheric pressure for 60 to 90 degrees C. Once the temperature is reached, then it goes straight to the expansion chamber, which is a lot larger, 34 liter, a 3 kilopascal of vacuum at room temperature. It produces the explosion that comes out as a product in a formula of a puree. The mango that we have, they have actually, I'm just friend of them, I'm not doing it myself, but my colleagues are processing have been Ataulfo mango, and more recently I've worked with Manila mango. Ataulfo was naturally appear as a variety from natural inbreedings, crossings of Carabao and other varieties, and was granted designation of origin in 2003. And it's basically the most successful variety for export in Mexico, mostly to the US. So what they obtained by flash détente is this pulp, very clean. The whole fruit explodes basically, and the pulp is obtained, which they can also be strained and filtered to have it the way the industry desired. If you see here from these treatments, the color of the one with the highest treatment remained the same, the luminosity, and the total difference as delta E remain unchanged compared with the time zero or control. And this is the appearance of the control pulp, which was obtained manually, or the different times of exposure to the steam and later to the process. Most people or most scientists or consumers could be concerned about antioxidant activity. What would happen to all this process? Well, it certainly does lose some volatiles that are important to the flavor, but they don't lose that much. The work is underway by GCMS to assess those losses. But see, the phenols content even increases, which means the process, the flash detonant releases more phenols and increases the antioxidant activity. At last, because we don't have much time, I found this process that's also been explored and investigated in my institute is the refractance window drying of mango puree. So basically you obtain the mango puree, and this comes basically from researchers from India. You have a circulating water bath, and there is a plastic film on top of which the mango puree is applied, and then it's slowly conveyed in this belt. This belt conveys the puree. When it gets to the other side, it's scraped with a blade like if it were a drum dryer. And then what you obtain is what sometimes they call a leather. That leather, you can just pack it as it is or dry it into mango powder. But what is the real advantage of using this process? If you see, a mango leather can be prepared by a refractive window, by tray drying, or by oven drying. The moisture is similar, but take a look at the drying time. Energy-wise, is more green than tray or oven drying. You will spend less money in energy, but then the other components are also very interesting. See, you retain more ascorbic acid than the other two processes. The same with the antioxidant. Hardness it's a softer product, and the color is even better. And the final water activity is basically the same. It's a good texture. It's a very appealing product. It's something that should be considered for those who are interested in the processing of mango. Okay, I hope I did keep the time as I was asked, and I would love to ask questions when the time comes. Thank you.
Yeah. Thank you, Professor Hugo. Really, it is very interesting talk, and we need the more time to understand all these technologies which you have explained. Sometime I will invite you for the long presentation, the single presentation of you on these processing technologies. Because today I have not invited my graduate students and PhD students there. And it is, I think it is very much interested to them also, and our food science and technology department also. So sometimes I invite you exclusively for our institute only for delivering this talk, and we can discuss all these things. Also, I will invite Professor Colelli from Italy for the fresh cuts at the same time. so that we are very much interested in the fresh cut technology of the mangoes also, which is very popular nowadays. So we take the question at the end, and we are running short of time also. So I invite the next speaker, Manuel Michael. Manuel Michael is there. I can see you. Welcome, Manuel. So Manuel Michael is from the National Mango Board, and he has joined the NMB in 2014 as the Executive Director, where he is responsible for developing and overseeing strategic goals, plans, and program initiatives that promote higher awareness and consumption of mangoes in the US. He is also responsible for fulfilling the organization's mission and vision. The NMB's mission is to increase the consumption of mango in the US by inspiring consumers and educating them about the culture, flavor, and nutrition of mangoes, while bringing the industry together. And the vision is for mangoes to move from being an exotic fruit to a daily necessity in every US household. Manuel has an agricultural background and has worked on issues that affect the produce industry for 16 years. Prior to joining the NMB, Manuel provided regulatory oversight to several federal government commodities programs for USDA's marketing, order and agreement division. Additionally, he has experience in quality assurance and food safety gained in Salinas Valley of California, and has also worked as a managing associate attorney in Texas. Manuel has undergraduate degree from Oregon State University and a doctor of jurisprudence from Texas Tech University. So with this introduction, I invite Dr. Manuel Michael from the National Mango Board for delivering his talk. Just a minute. Change your role as presenter as well as, yeah.
Hear me, Dr. Parikh?
Yeah, I can hear you.
Okay, thank you. Let me go ahead and share my screen here. Let's see.
It is coming.
Okay, can you see my presentation now?
Yeah.
Okay,
It is very
thank
much
you.
clear.
All right, thank you, Dr. Parikh. Thank you for the introduction, and also thank you and the organizing committee for putting together this event. It's very important, even though with the pandemic, we cannot travel, we cannot get together like we used to. It's still very important for the mango industry to come together, share information, share knowledge. So I really appreciate and commend you and Niftem for putting together this event, and also to the other speakers who are participating in today's webinar. Today's presentation that I will be giving will focus in 4 main areas. First of all, I'll talk about the National Mango Board very briefly. Then I'll cover the world leaders in mango production and global trade. We'll cover just briefly the US export standards or protocols, and then we'll look at US mango consumption. So the National Mango Board was developed in 2005. And the reason it was developed was so that consumers here in the US would be introduced to mango and to increase mango consumption so that the industry would grow over time. And so that was the main purpose of why the Mango Board was developed in 2005. Since then, we have a mission that continues to be increasing mango consumption, and we do this by inspiring consumers to eat mango, to learn about it, to educate them about the culture and the flavor and about the nutrition content of mango. And then at the same time, we work with the industry to share information and to bring the industry together. Our vision is for mango here in the US to move from becoming just an exotic fruit to becoming a daily necessity with each household. And then we do also have strategic objectives. There's one that is focused for the next 4 to 5 years, which is to move mango into a top 15 fruit in the market in terms of value. Another goal that we have more long-term is for the next 10 years for mango to become a top 10 fruit consumed in the US as well. We have also strategic priorities to help us guide us in our mission and our vision. The first one is to deliver high quality, flavorful mangoes. So we work with the industry to make sure that this is being accomplished. As we have heard from the other speakers, mangoes can be complicated because they travel so far away to come to the US, and it is complicated. So there's a lot of work that we're doing there to help educate the industry, to also answer questions that may exist on how to improve the handling. When it comes to market positioning, we want to make sure that mangoes are available and then also that the consumer sees them favorably, that the retailers know that mangoes are high sellers, and also that at food service, that mangoes can be used in many different ways. We also want to educate the consumers, as I have already mentioned. We also want to make sure that mangoes are available year round. As the National Mango Board, we're mostly focused on fresh mango consumption. But in the sense that we're increasing fresh mango consumption, we're also increasing processed mango consumption. So this is important to have mango available in all its forms everywhere. And then finally, of course, we focus on the industry service and engagement. We have a board of directors, which is made up of 18 members. Here in this picture, which was taken about 3 weeks ago, we have 15 of those board members. These include 8 importers that represent the US from the West Coast all the way to the East Coast. We also have 7 foreign producers on this board. We have 2 domestic producers. One of them currently is from California, the other one from Florida. And then we have 1 first handler for a total of 18 board members. And they are the ones who guide us. They're the ones who make all the decisions on which projects, which campaigns we will move forward with. Now, when it comes to fulfilling that mission and the strategic priorities, we also have programs in place which are managed by the staff here at the Mango Board. And there are 2 main programs. The first one is marketing and communications. And the responsibility of this program is to focus on the consumer education. We also do nutrition and health messaging. Several of the speakers today have mentioned about the benefits that mango have, and there's a lot of new information that is going to be generated here in the short term, in the next year or 2, that's going to make mango even more interesting to consumers. We also work with the retail industry, with the food service industry, and then of course we do a lot of public relations and communications, all in the effort of keeping mango top of mind and for mango to have a positive view so that the consumer sees it favorably. And then, as also mentioned by speakers earlier today, ripening has become very important to make sure that we do increase consumption and to have more consistent quality. And then more recently, in the last year, we have been focusing more on fresh cut because we know there's a lot of potential there, and it's a way to get consumers to eat more mango. The second program we have in place is the Research and Industry Relations Program. And that's where we start working when it comes to the nutrition and health research. Unfortunately, I cannot go into a lot of detail here today for lack of time, but we do plan to share more information here in the near future. Another important factor that the research industry or the research program does with industry relations is to have information that we can share with the importers and with the retailers. So crop projections becomes very important so everybody knows what to expect. We do a lot of research around production and post-harvest practices. In the past, we were focused on food safety, and we continue to support food safety information and education. Sustainability is another topic that is a focus of ours in the last couple of years. And then, of course, the industry and relations focus that we have. So moving on to who the world leaders in mango production, exports, and imports are. This graph that we have in front of us has information from the United Nations Food and Agriculture Organization. And a couple of caveats. First, this is information from 2019. It's gathered by the United Nations, and it includes 3 commodities: mango, guava, and mangosteen. This is how they collect the information and how they present it. We know that mango is overwhelming the most important fruit of these three. And so this is what we use to measure what's going on around the globe. As you can see, India is the #1 producer of mangoes with 25.6 million tons of mangoes in 2019. When you take the following 9 countries on the list, they do not add up to the volume of mango that India produces. So India is a very important producer of mango. Other parts of the world that are important, of course, here in Asia, but then Latin America, as it has already been mentioned, also produces mango, with Mexico, Brazil being in the top 10 list. There's also production in Africa, Egypt being within the top 10 also, and then Malawi as well. When it comes to the exports, this changes from the previous graph, and we see that Mexico is the country that exports the most mangoes throughout the world. They export approximately 413,000 tons. That's what they did in 2019. After that, there are several countries that are grouped together, about 5 countries, Thailand, Netherlands, Brazil, Peru, and Vietnam. With the Netherlands, they, as you know, they don't produce mango, but they do import a lot of mango and then redistribute it from there to the rest of Europe. So that's why they appear as a top exporter. Then, of course, we have other countries such as India, Pakistan, Ecuador, and Spain, who also are exporting mangoes, and these are producers of mango that are then sending their product out to the rest of the world. When it comes to imports, the U.S. is the top importer of mango with 493,000 metric tons in 2019. As we mentioned, Netherlands is also an importer, and then they export it out to the rest of Europe. Other countries that also are very involved with the import of mango are here within the European Union, and then there are other areas here such as Vietnam, and then Saudi Arabia and the United Arab Emirates are also large importers of mango. Now, when we look at the U.S. mango market in more detail, first of all, I want to start off with the protocols or the standards for mango, and the main one that we focus on are the phytosanitary protocols. These have also been mentioned earlier today, but within the U.S. Department of Agriculture is the one who oversees the implementation of these protocols, and specifically the Animal Plant and Health Inspection Service is the one who is responsible to make sure that all these standards are being implemented and enforced, that they're science-based, and most importantly, that they allow for safe trade of agricultural products to the U.S. The main key is to avoid any sort of pests being introduced into U.S. agriculture. And so the process can be summarized very simply. If a country wants to export a product to the U.S., there are 3 steps that are followed. First of all, there has to be a commodity import request. That's usually done at a very high level with the U.S. Trade Representative working with foreign governments to start the process. After that, a pest risk analysis is conducted, and that's what's listed here. There's a whole process to analyze whether there are any pests within the commodity and what are different ways that can be used to minimize those pests or reduce them entirely. Once it's been approved that there is a way to safely export any product, in this case mangoes, to the U.S., then there's a regulatory or administrative process that is the next step. And there, the plant protection and quarantine part of APHIS is involved. There's a process called the Q56 regulations, and it's pretty much administrative. Once they have all the information of what's needed to get mangoes into the U.S. safely, it used to take about 4 to 5 years for the regulatory process to be finalized. Now it's taking anywhere between 1 to 3 years. So it has improved, but it's still a fairly slow process to make sure that all the regulations are in place. Within APHIS, there's a resource called the Fruit and Vegetable Import Requirements webpage called FAVIR. And here in FAVIR, it has the list of all the countries that can export mango and also any other commodity to the U.S. and what regulations or what protocols need to be followed when it comes to phytosanitary to get those products into the U.S. For India, there is one protocol that's allowed for mango exports. It's irradiation, and it's irradiation that needs to be done in the country of origin. It's called T105-52. And so I've provided a link here so that if you're interested in learning more on the process that needs to be followed to irradiate mangoes in India to get them to the US, it's all outlined here. And again, it also provides information for any other country that wants to or that exports mango and other products to the US. There are currently 21 different countries that can export mango to the US because they have phytosanitary protocols in place. This list here are those 21 countries. The most recently country that was added to the list is Colombia. This happened, I think, about 2 or 3 weeks ago, so just recently. This list does change over time. There's usually maybe 1 or 2 countries that are added or subtracted from this list on an annual basis. And I've placed a star next to the countries that have exported mango to the US in 2020 and 2021. Due to the pandemic, APHIS decided not to allow exports of mangoes from all countries, including India is one of the countries that has been affected. And so there haven't been USDA or APHIS inspectors in all the countries. And so there needs to be a process where they do the inspection and accept the shipments so that they can go out to the US. And that has not been in place in India for the last couple of years. We talked earlier today about all the different mango varieties that exist around the world. Within the US, there are 5 to 6 varieties that are managed at a commercial level. Tommy Atkins being the most common variety, then followed by Kent, Ataulfo, Keat, and Hayden, and then Francis. And all these added together make up about 99.5% of the varieties that are handled or that arrive here in the US. So only about 0.5% represent all the other varieties, and those include from India, the Alfonso and Kesar variety. We also see some Malika starting to come into the US. I'm not sure if Malika is coming from India or if it's being produced in other countries, but we do see that variety here. Also, other varieties that are starting to become more popular are Nam Dok Mai from Thailand, which is also produced outside of Thailand. Within Dominican Republic and the Caribbean, we see several varieties like Mingolo, Banilejo, Julie from Jamaica. And then Australia also was added to the list about 4 or 5 years ago, and they have been sending Kensington and Calypso varieties here to the US. So this list of the most common commercial varieties is changing over time. Tommy Atkins used to be the majority by far, and over time it's become less popular. Kent is a variety that started picking up a lot of attention in the last 5 years. Originally, the consumers did not like Kent because it did not develop that bright red color that Tommy Atkins can have. And so once we started educating consumers that Kent was a great tasting mango, that it was available, that don't judge mango by the color of the skin, to judge it by other characteristics, then Kent started to take off. Ataulfo is also a variety that is originally from Mexico that has been growing over time. But Ataulfo, like many mango varieties, do best in their country of origin where they first came to be. And so Ataulfo is produced in the other parts of the world, but it's not as successful as it is in Mexico. So the growth of Ataulfo has been limited. There has been a lot of plantings done around the world, but some of them have not been as successful as the industry had hoped. Key is another variety that has been growing over time, especially at the end of the Mexican season, which is around September, October. And then in Southern California, there is some production, and Key is the main variety there. And then, as has been mentioned earlier, Hayden was one of those varieties that was first developed here in the US back in 1900, 1910 or so. And over time, it has lost the amount of mango that is produced around the world. And then Francis is from Haiti. When we look at the volume that was imported in 2020, Mexico usually represents about 63 to 65% of the total volume that comes to the US. Last year, Peru jumped up ahead. Brazil went down, and then Ecuador also went down a bit. But this year, these countries have rebounded. And so between Ecuador, Brazil, and Peru, we usually see about 10 to 15% of the total volume from each country, followed by Guatemala. And then the other 16 countries send about 3% of the remaining volume. When you take those top 5 countries that export the most mango to the US, this graph shows the growth of the imports and also the value over time since 2005. And what we see is that we have consistent growth. And the volume has grown 112% since 2005, but the value has grown by 152%. So this shows that consumers in the US are valuing mango more over time. It's very good sign when the value is going faster than the volume, and both are growing steadily over time. We looked at the imports from India to have an idea of what these look like. And also starting to measure in 2005, there were only about 20 metric tons exported those years. And in recent years, the last 4 or 5 years before the pandemic hit, the mangoes from India were really starting to take off, not just in volume, but also in the value that they generate. So it was encouraging to see this growth, but then due to the pandemic, the exports from India have stopped completely in the last 2 years. Hopefully that changes soon. Moving on to mango consumption here in the US, this graph shows the growth of mango per capita consumption since 2005. And what we see is that it's grown by 93% increase. If you recall, 2 slides back, we talked about the volume increasing by, I think, 113%. And one of the things that was mentioned earlier today was the shrink, or the mangoes that are lost when they're packed, harvested, and then sent to their destinations. And so within the US, we have done studies and we know that the shrink is anywhere between 15 to 20%. It's quite high. And so that's something that we're working on as an industry to try to reduce that shrink, because once you pack the mango, you've invested a lot of time and money into it, and you want to make sure that you can sell it so that the consumer enjoys it and that it generates value. If you lose that shrink in the distribution chain, then it's not good for the industry. So when you compare mango and how it's changed the consumption over time, this graph shows us all fruit consumption in the US for the top 23 fruits. And back in 2005, mangoes were the number 17 fruit with 1.9 pounds per person per capita consumption per year. This has increased to 3.17 pounds of per capita consumption in 2018, and mango has moved up to the number 13 fruit. You can see how the other fruits have adjusted over time, but mango is one of those fruits that is growing in consumption. In 2020, of course, we hit about 3.6 pounds of mango. This is still very low consumption. For those of us that love mango, during mango season, we can eat 3.6 pounds in one day. So there's a lot of room for growth. We know that US consumers do like mango. As they become familiar with it and know the different varieties, that consumption is increasing. So we feel that sky is the limit in how much we can increase mango consumption. This graph shows the the retail sales in 2020 measured by volume. And here we see that mango moved up to number 12th position. Most of the fruits in the US did very well last year. Due to the pandemic, consumers were concerned about their nutrition and health, and so there was a lot more consumption. Also, what shifted was that a lot of the fruit that is consumed within the food service channel was needed to be moved over into retail. And so that's why we see a lot of growth here last year. But to summarize it, mango was one of the main fruits that grew in consumption at retail last year. It was citrus, avocados, and berries, and mangoes. So mangoes were in the top 4 of the most consumed growth in 2020. When we look at mangoes in terms of the value that it generated, the mangoes moved up from the number 20 position up to number 17. And it was a growth of 19.4%. And here you do see other commodities that also did well. Again, mostly the citrus, cherries, and mangoes. Those were the 3 fruit or categories that grew the most in 2020. For this year, we're also going to continue to see growth with mangoes, not as much as we did see last year, but every year we continue to see more and more growth in mango consumption and also the value that's being generated. So as the National Mango Board, our goal is to continue to grow mango consumption. And our vision is that mangoes are going to move into a top 15 fruit and into a top 10 fruit. As I mentioned before, we're already number 12 as of last year when we had 3.6 pounds per person of per capita consumption, but we continue to grow. And in the next 4 to 5 years, we want to hit the goal of 5.3 pounds of consumption per person and then move up to 7.1 pounds within the next 10 years. And so all this is within our grasp. We think that we are going to achieve this growth. To achieve this growth, it means that we need to generate also more imports from all the different countries. To grow, to double the volume in the next 10 years is not easy, but we know that there are a lot of countries that are interested in sending mangoes to the US. And so we'll continue working with the industries to get more imports and then also to expand the volumes and the different varieties that are available to US consumers. So I've cut back my presentation, but if there are any questions, if you would like to send any questions in the future, please feel free to send me an email, and I look forward to continuing this discussion on mangoes. And Dr. Parikh, thank you again for the invitation.
Yeah, thank you, Dr. Manuel. It is very nice and precise presentation, which gives the whole scenario of the mango import-export and all the statistics you have given. And the variety wise, you have given that what varieties are important in the world market. We are producing here the very good varieties like Alfonso, Kesar, Amrapali. Then nowadays, Ambika is becoming very popular. So that how we can export it and how we become in the world market. So I will arrange one meeting of you along with the top policy makers like the Secretary Agriculture or the Secretary Commerce of the government, as well as our ICR system and National Horticulture Board members also. So we will discuss at some platform in the coming time so that how we can collaborate for the mango export, import and the world trade. So with these words, I really thank you from the core of my heart that on a very simple invitation, you are here with us and give us the time in the early morning there. And now I invite our last speaker, Dr. Shrikant Sheel. Dr. Shrikant Sheel is from the Bangladesh Agricultural University, and he developed the professional with over 33 years experience in the field of value chain analysis, party agriculture and industry. He has been working intermittently as international supply chain expert in Andhra Pradesh irrigation and livelihood improvement project in India as a JICA funded project from 2019, an international seed commercialization and intellectual property rights expert in climate friendly agribusiness value chain sector project and ADB funded project of Cambodia from Jan 2020. In addition, currently he is also working for ADB headquarter Manila as an ADB staff consultant of agricultural value chain specialist in designing the value chain components of a proposed project in Bangladesh to be funded by ADB, IFAD and government of Bangladesh and for World Bank. Washington DC as a logistic expert in VKA project in Bangladesh. Dr. Sheel worked in a number of development projects funded by FAO, UNDP, the World Bank, USAID, ADB, IFAD, IFC, SCDF, European Union, UKAID, DANIDA, then SDC, ICUC, and Government of Netherlands in long-term and short-term assignments, in including 6 years experience in 10 countries as international consultant under FAO and UNDP in FAO headquarters, Rome, Italy, Morocco, India, Bangkok, Thailand, Laos, Myanmar, Timor-Leste, and North Korea and Afghanistan. Before that, he worked for Bangladesh Agricultural Research Institute as a researcher over 14 years and as a national consultant in diverse development projects and private sector agribusiness and agro-processing industry planning for over 12 years. So with this introduction, I invite Dr. Shrikanta Sheel for enlighten us on the value chain development in case of mango in view of the world trade and how we can improve our value chains in the mango. Professor Sheel. You are muted actually.
Oh, yeah, yeah, yeah. Now it is clear. Okay, thank you very much for giving me the opportunity for presenting in this valuable event. I would like to thank you, Dr. Porte, and also to the authority of Niftem for giving me the opportunity for presenting the value chain constraint and opportunities, and as well as for how to the value chain development opportunities here. So can I share? Is it? Can you?
You can share from. You can share from there.
Let me try. It would be nice for me. I didn't get any. Have you given me the?
So
Have you
please share.
allowed me for this sharing?
Okay.
Okay.
Now you try.
Okay, fine. Let me try. But not yet. Not yet allowing.
Make you host. Now you can try.
Yeah. Not possible like Professor Al-Hadi.
Someone is playing with today's.
Maybe something problem I'm facing here. Better from your end, if you,
Just a moment. I leave and again join.
yeah.
Now you can try.
But the same thing is happening. System prevalence. Not yet possible. Same thing is happening.
Then just a moment.
Better we can share.
Okay, there is problem. Give me 1 minute.
Okay. Yes. I think.
Is it visible?
Yeah, it is visible. It is visible, but you are controlling that one, right?
Yeah, so I will move the slides. You can continue.
Okay, that would be nice. That would be nice because sometimes it is under control. So, thank you very much. Yeah, please next. Yeah, as we know that mango origination actually started from 2000 BC in India, and then it is transferred in East Asia 500 and 400 BC among this time. And after that, theme is that in the 15th century, it is transferred to Africa and Brazil, and 16th century in Africa and Brazil, and 15th is in the Philippines. So thing is that where is the origination? We are in the Indian subcontinent. Actually, we can see to the back now what is our performance. Actually, the valuation starts on the market demand, and its performance depends on how the whole operation is going on. Yeah, please. Before that, I would like to share some slides on market overview, although it has been shared by Mr. Michael, has been given in detail, but some slides I will discuss in detail. Yeah, next, please. Next, please. Yeah, this is actually the before previous slide, previous one, previous one, previous one, previous one. Yeah. Yeah, mango production, although it has been, I have given, sorry, next one. Here is the mango production status, what data I have collected from a journal, that is 2018 data is here. And it is the 25 largest mango growers. India is the, maybe it is below 2018 when it was around 19 million metric ton it was produced. Then it is gradually, these are the most largest countries of the world who are producing the mango. But to my objective is to see that who are the producers and who are the exporters. I have to compare these two groups simultaneously. Next, please. Yeah, here are the 15 exporters we have seen. They are actually there. Some of them are here in a good performance, but some are still lacking their performance in terms of export, what we see. And here is the export volume, and we can see the next slide. Next slide, please. Here the export share, actually what we can see, who are the producers and who are the exporter. We can see clearly here some difference is being shown here, and I have to find out somewhat strategic or some causes for due to this difference, and what is the causes for this performance difference we can see. The next one, please. Here we can see, if we divide into two groups, the Asian countries who are covered under this top 15 and other countries among the top 15, all the whole 15 exporters, we can see the Asian countries is beyond, that is their performance, export performance is lower than the other countries coverage among the top 15. So this is thing. On the other hand, if we think that these Asian countries who are lacking their export performance, they are the largest producer of the world. This is the important point what we see. Similarly, we can see who are the importers here, actually the importing countries. Here, China in the Asian region, China is the biggest importer, and then USA in that part, then Netherlands, Germany, Hong Kong, United Kingdom, France, Canada, and Russian Federation by this way. And if we compare this table with this graph with the production status, we can see in the next one. Here is the percentage coverage by the importing countries, and the next one is the comparison. We can see, yeah, here is also there is a big difference. We can find the Asian countries are importing a very lower amount of mango, but in terms of other countries, they are importing more. Okay, then next, please. Yeah, this table is very important. I would like to say that here is the first column, the comparison with this data in 2018, because the latest data is not available. So if we see the rank of producer and rank of exporter simultaneously in two columns, we can see, for example, India is the largest producer. Its rank as a exporter is 7. China is second producer, exporter, rank is 11. But Thailand is okay. Thailand, Mexico, their production and export proportion is very nice. Indonesia, also the similar group we can see. Similarly, Egypt, Bangladesh, Nigeria, Philippines, although they are the good producer, but export performance is very low. So by this table, we can see some observation we can find from here is that the export, actually these South Asian countries, the biggest market is here, South Asian countries is actually the China, then Korea, and here is the Middle East. And the other market area is the Western countries of the world, is that part, America and US, Canada, the European countries. So theme is that the distance factor is an important issue what we are finding for the South Asian countries. And this is why the geographical location is an important factor we can see for fresh mango, because fresh mango export requires too much care about that, because its shelf life is very low. And the CA storage or other high-tech storage technology transportation is also very costly. This is also important issue. And processed mango export is a good option for these South Asian countries. I am not telling that it is not should be important. Also to be strategy to be developed, analyzing all of this aspect and considering this transportation cost regarding this. Here is the food safety and quality assurance for processed mango products would be competitive for export market. This is one important issue for the South Asian countries particularly. And here for value chain development for processed mango should be given more emphasis, as fresh mango production export is highly challenging for South Asian countries. Next, please. And point of this, particularly the challenges I would like to discuss regarding the increasing competitiveness in mango value chain, linking the access to export, particularly for developing countries. If we see what are the major constraints or barriers regarding to increase their competitiveness in compared to the larger scale exporters, the biggest exporter, what is their performance and what is the developing countries export performance. If we see some benchmark region in regard to value chain strategy, we can find all of these things, that what we needed to upgrade the status of the quality and all the value chain strategy. Next, please. Here we can see the market system. Market system, we can give a look here. There is the value chain consists three things actually. Here is the valuation actors who are working with their operation, enabling environment, and service providers. These are the three components of a market system. But valuation is the central position what we needed to give more emphasis on that issue. So constraints lies on these steps. Where are the problems prevailing in the valuation? We can have to find out systematically with this market system packaging market system steps. We have to see the here is major constraint we can find actually the quality control issues, that is quality assurance aspect, that diversified kinds of standard what are required. For example, BRCGS, GMP, HACCP, GASP, GAP, many things, many kinds of issues. It depends on actually country to country, importing country to country, it will vary. So before making a marketing strategy, we have to see what are their requirement, that is the buyer's requirement, what are they, what kind of strategies, what kind of specifications they are recommending, what are their needs, all those to be studied. And before that, another important issue is that what are the benchmarking that to be finalized, and why this quality product and this valuation system, that is the prevailing valuation in hot condition, hot existing status, they are prevailing in their country. So all of these things to be standardized, that is to be known first, and then how much work to be needed, what to be needed to increase their competitiveness, we have to see step by step. Yeah, next please. First of all, we can see the valuation actors who are actually the producer, starting from input supplier, producer, processor, traders, distributors, wholesalers, and retailers. All of these valuation actors, how they are performing. They are still lacks the common effective platform among the valuation actors, as valuation integrates all of these actors together to make a final product. So their platform is very important. Vertical linkage, if we see, there is very weak linkage, particularly for developing countries, lack of opportunity for traceability issues, lack of blockchain technology, not initiated actually. Just it's a very beginning stage, we can see. Then next please. Yes, service providers who are involved with this market system, that is very important, who are giving the service, different kinds of service, private sector service provider and technological service provider, business promotion service provider. All these things is very important to be addressed under this. If we see the service providers, how much knowledge they have. In our survey or study, we have found in some this kind of developing countries, the lack of proper skill in this issue is a very important issue. Technological service provider is still the technological service and updated technology is lacks, but although the technology is available, but to transfer of technology is very weak. Still there is a weakness for transferring those technologies to the valuation actors. That is important. Another important thing is that the business promotion service provider, business incubator service provider is a very important operation maybe in terms of valuation development. that is actually initiated in some areas of the developing countries, but still they are lacking. So this is also important. Next, please. Then business enabling environment. First, the formal laws, regulation, policies. That is very important. If there is any compliance gap, lacking international market standard in most cases. Actually, what is the international market status? We don't know. Particularly the mangoes are going to Western countries or other countries. Mostly the consumers are the ethnic people who are going from this South Asian countries to other countries. They are the major consumer. But retail chain achieving is still very, very tough for lacking our quality update or quality status at this moment. So this is why this is very important points. Another thing is informal norms, customs, code of conduct is also to be addressed. Public infrastructure, that is our infrastructural problem, is very important. Also, in some development projects, ADB, World Bank, or other donor agencies are giving some technological assistance for developing, but still it is not sufficient for changing the situation. So these are the major issues. Nowadays, everything is developing with machinery, infrastructure, road construction, electricity, everything is a very important factor. Infrastructural situation to be important. So developing country still lacking this major issue that has to be developed simultaneously with the value chain development. Healthy and appropriately skilled workforce is lacking. That is also very important. Our institutions, research institutions, academic institutions is trying to make more technologists. That is very important initiative, and still it has to be also strengthened again to develop and giving the technological service on this sector. Next, please. Next, please. Yeah, value chain operation. Step by step, if we see, the previous slide, please. Please go to the previous slide. Yeah, thank you. Input supply is the starting point for value chain. Yeah, input supply, the initial stage of value chain operations, that is very important. Quality fertilizer, insecticides, training services, everything. That is mango. In case of mango, there is a grafting service, and the quality variety is very important. Also, these are the sector for input supply case. Also, the machinery and other things, other supporting things are very important issue to be supplied fluently. Still, we don't have the agricultural mechanization is still lacking their performance in that positions. This is in the developing stage. Production management in traditional production management activities resulting low productivity. So it has to be improved. Use of improved technologies at a lower level. Improved technology just is initiated, but it has to be strengthened. Production cost higher in compared to yield. This is a very important, crucial point. Although we are investing more, but yield is low. There are so many causes. It has to be found out and to address the constant. Use of chemical fertilizer, pesticide insufficiently, farm machinery, lack of ease in financial service. That is also important point. The farmer groups, the FPO who are working, frequently they are asking about the financial services. They are lacking their fund, how they can initiate the valuation activity. Yeah, post-harvest handling, major problem. It has been discussed in detail, our earlier speakers in many times. So this post-harvest handling activities, packhouse operation, still we are lacking, and every step are still underdeveloped. We have to give more emphasis on this issue because these are the quality control most important points where the interventions to be required. Next, please. Secondary processing industry, what number of secondary processing industry is prevailing in compared to the population it is still not sufficient. So in this regard, value adding commercial initiatives are to be given more emphasis as because as we know that fresh mango export market is highly challenging for this region particularly. So if the value added product with a longer shelf life can be developed, that is the good option for South Asian countries. Yeah, there are some initiatives are going on, mango product, mango paste, mango puri in many places of India has been initiated and doing good performance also, but yet there are more emphasis to be given to strengthen all and to increase their volume. Food safety and quality assurance issues, particularly for the farmers' post-harvest management and production level, that is good agricultural practice is still lacking for fresh market producer. That is the export market is demanding global gap. For example, Kenya has started for Kenya gap, but while they are exporting, there one example we have found that Kenya gap is not allowed by those Western countries importers. So then they have to study for global gap how to establish it one. So South Asian countries, including India, all of these countries should take this important issue that how to establish this global gap, how it is possible. This is a very big concern for mango production and post-harvest management or towards the exporting the product. So market access and inter-farm relationship activity is very important, crucial point because lack of farmers meaningful horizontal integration. If there is a domestic marketing concept, it also necessary for farmers horizontal integration with just like the farmers producer organization in developing project. Yes, there are good initiation is started in many areas of India, Bangladesh or other countries. I have seen, so these are the good initiative for FPO development and interaction with that to make their economy of a scale increasing their production and getting good market value for them. So lack of common standard facility. Everyone is doing their facility individually, but it has been found that in many valuation development projects, we have found that common standard facility for market system is a good initiative. It can be when a group is working together and market together all of these mango products or other products, they are doing good. and they are getting more benefit following these steps. In many cases, market location is far from their field. That is also important point, because it is very shortly after harvest, it requires the pre-cooling system to reduce the respiration rate. So that is also very problem. This pre-cooling step is very much hampered, and that is the major constraint for reducing the shelf life. In some practical experience we have found. So this pre-cooler, like Air Force cooler, what Professor Al-Hadi has recommended, that Air Force system cooling is very costly for the poor farmers. That is a very important point. So networking among farmer traders, very important, particularly for vertical integration aspect. That has to be also important. Yeah, please. Next, please. Second, recommendation now, what I told earlier, that the benchmarking issue I discussed in that, actually, what are the position of the present situation of the commodity. We have to study. There is a baseline study to be done in a specific area, that from that baseline, how must that area to be developed to gain its competitiveness. That is very important issue. So what are the status of quality? What are the status of variety, market situation? Everything to be measured first. That is called the benchmarking. That is very important. Then if the business incubation system, particularly for processing and post-harvest management sector, this business incubation system is very important. And regarding the quality assurance and improved quality standard, we have discussed in many that the global gap and other for industrial processing, GMP has up very important. And nowadays it is very important for food safety management systems. So for processing industries, if this system is maintained, there is a good scope for marketing as well as the quality assurance also to be ensured. So newly some standard like sustainable forest management system, this is also important. And similarly, there are some other private standard. It depends on the importer, what kind of importer, and demanding what kind of standard. That has to be measured, and that has to be collected, those data. That is important. And one step establishing one step center, that is a business incubation system, that has to be together with this, that can enhance the value chain management system properly. It has to be given along with the blockchain system. Nowadays is getting more popular to manage all the value chain management and development mechanism. That is a including the market system and market access, all of these things. So blockchain system to be established very nicely in every initiative. That is a good option. Yeah. So there are some essential standard, that is British Retail Consortium, BRC, for this WTO mentioned, all those things to be necessary for that. Next, please. introducing, already I discussed on that blockchain technology, and then aggregation model. Actually, they encourage and promote aggregation models to bring economies of scale. What is the evaluation management system, the basic strategy that aggregation models such as productive partnership, contract farming, or producer group, among others, need to be encouraged to facilitate the delivery of extension service. This aggregation model will help a combined or composite activity together that is necessary for value chain development. That will improve farmers' ability to access their finance, develop joint infrastructure, lowering market logistic cost, and better connect with large buyers and off-takers. So this is the model that has to be initiated. In improving marketing infrastructure that and logistic service, very essential, facilitate access to finance for value chain actors. To be finance must be ensured in the value chain context, and also the policy interventions. We have to require some specific policy for management of value chain. So we have to see first what are the benchmarking of policy, what are the lackings, that is also to be measured. If there is any policy reform is required, that is important. So to proper activity for the enabling environment, policy is a very important issue to be addressed. Next, please. Yeah, now conclusion, particularly for developing countries, what is mostly applicable for South Asian countries. The geographical location is not much favorable for fresh mango export, as the larger export market is far requiring huge cost for air cargo transportation. This is the important cost for transferring mango, fresh mango to the larger exporter. For example, Mexico is the neighbor who can easily transfer their mango to America, US, very easily, very low cost. So in compared to Mexico, how can India make that privilege? That is very important point. So processed mango, that is why processed mango is a good option for South Asian countries. And for this processed mango, that is very important, is food safety and quality assurance must be ensured to make itself as a competitive for the export market. The value chain development for processed mango must be given more emphasis for South Asian countries. And thus, I'm finishing that one. Okay. So value chain approach that are inclusive of emphasizing post-harvest loss reduction, that is a very important point, and quality assurance, essentially standard as well as appropriate marketing strategy must be required towards enhancing the competitiveness of mango subsector. Thank you very much. Thank you.
Thank you very much, Dr. Shikanta. So now we are at the end of this 5 hours long meeting, and all of you are stayed here for the last 5 hours, maybe in the very odd time. Here in India, it is almost the midnight, 11 o'clock at the night. In the other countries also, it may be the morning or it may be the afternoon, or somewhere it is the night. In the Bangladesh also, it is the night. So I am really thankful to all of you that you share your knowledge here with all of us. And I don't know, there is some problem today is hacking. And even though in between that, I see that the parallel sessions are also there. And participants are at this in the two systems. I don't know how it is possible, but it has done today. I will see later on. But I thanks all our valuable speakers, particularly I thanks to our Deputy Director General, Professor A.K. Singh, who has joined and gave us the overall scenario of the Indian mangoes. I also thanks to Dr. Shailendra Rajan. In spite of that, there is the wedding in his family only, and he stayed here and he given his valuable talk. And he has sent me a message that he is editing one important journal of applied horticulture. This journal is in the Scopus Index as well as in the Web of Science. So he is kindly consented for the one special issue on the theme of this webinar, and all our speakers can send the papers for the publication as a lead papers in that volume. And also we will invite the important papers from the other participants, and one special issue will be brought out on this theme. So I thankful to him also. Then Jeffrey Brecht has enlightened us on the biology, post-harvest physiology, and the phytochemical compounds in detail. And Al-Hadi Yahya has given, I can say, the main talk on the post-harvest handling and the management, and the overall scenario as well as the technologies which are important for the post-harvest handling, and how we can extend the shelf life and the supply chain management, better supply chain management by the technologies. That is the need of the hour. Professor Garcia has given a very beautiful talk on the processing technologies and the processed products. And really, we think that the time was too short for his talk, and we will invite him for some time for some lengthy talk also. Dr. Michael is unparalleledly give us all the scenarios of the export, import, and what are the standards followed in the US, and how we can collaborate for the world trade and for the betterment of the mango industry throughout the world. And lastly, Shrikanta Sheel has given us all the steps that should be followed for the better value chain management, and what are the actors in the value chain management, and how we can address all these issues. Better if he sent us some case studies on the value chain management of the mango for the publication as well, and for the circulation to the participants. I request to all the worthy speakers that better they send their presentations even in the PDF form, so that we can circulate among all the participants. And also we will make the proceedings of this webinar, which will give to the government of India and other organizations also. And it will be the foundation for the mango industry, and how we can improve the post-harvest management and the processing of the mango, not only in India, but in the other countries. So I thanks all of you, and time is not permitting for the detailed discussion now, but we can take few questions, most important questions, and therefore I allow all the attendees to unmute themselves, and if they want to ask some important questions, then they can unmute themselves and ask the question by name to whom they address the questions. If any of the question, we welcome.
Hi, Sunil.
Yeah.
Hi, Sunil. This is Rajesh Sridhar from, I'm the head of the procurement for Super Plum.
Yes.
I'm
Please
really thankful.
ask your question.
Yeah, am I audible?
Yeah.
I'm really thankful for you for organizing such a wonderful webinar with all the experts who are in here. And they have given a beautiful presentation over here. I much appreciate on this. My question was to Elhadi Yahia. He had, hello? Am I audible?
Yes, you are very much audible.
Okay, thank you. So my question is to Elhadi Yahia. Sir, actually, basically, we are facing a lot of issues in maintaining the quality standards in the Indian mangoes, especially in the North Indian mangoes, which are harvested in the time of July to August, June to August, mainly in the anthracnose and this thing. We have tried with the hot water treatment, basically for the domestic market, but we have not much gained any positive responses with that. I mean, my question is, what else can we try for this to improvise this?
Okay,
Maybe some of,
go ahead.
maybe some of the competitors also might have tried on the hot water treatment for Indian mangoes, but not much, especially during the July, August, because of the heavy rains might be.
Okay. Obviously, hot water treatments alone is not enough. You have to do all the other precautions and preventions that we've mentioned. The field practices, the pre-harvest field practices are very important, especially when you expect heavy infestations due to heavy rain, high humidity, high infections, etc. I hope you have noticed the development of the microorganism during the pre-harvest. And then, of course, very essential, very important that the careful harvesting. Very essential, very important, cooling the fruit as soon as possible. If you have, if you can pre-cool it by mechanically, that's important. Otherwise, at least cooling it, at least not to let it to heat up. Okay, I cannot tell you about the chemicals that you can use. I assume that you need to use some chemicals. The chemicals that you need to use should be those that are authorized in your regions, and your and your local phytosanitary authorities should tell you, should decide what chemicals can be used and when, at what concentration, etc. Now, you do that, and then the hot water treatment is always effective, very effective for disease control, including for anthracnose. Anthracnose is the most difficult one, but hot treatment is very effective even for anthracnose. Now, you have to understand that hot water treatment application and system is very, very different from one cultivar to another, and from one purpose to another, okay? And not all the mango cultivar are sensitive to different temperature and different durations. The most effective hot water treatments for decay, for disease, for controlled disease, and is from about 48 degrees Celsius to about 54 degrees Celsius from 3 minutes to 20 minutes. And I'm giving you this range because we have to check based on your cultivars. Some cultivars are more sensitive to higher temperature. Some cultivars are more sensitive to longer duration. So check temperatures, do the previous things, do the previous handling things, careful handling in the field, the pre-harvest control, careful harvest, careful packing, cooling if possible by water and by forced air cooling if possible, and try the hot water treatment. It's always effective. I can assure you it's effective, but you need to experiment. You need to, depending on your cultivar, I don't know what cultivar you have, and also will depend on the maturity and ripening stage of your fruit. But temperature somewhere from 48 degrees Celsius to somewhere 54, 55 degrees Celsius, from 3 minutes to a maximum of 20 minutes. 20 minutes when the temperature is the lowest, and about 3 minutes when the temperature is the highest. And I will assure you that you will have solved the problem.
Thank you very much. One more question I have. I'm just checking our process is right or wrong. Basically, what we do is we harvest the material, we desap it. After desapping, we'll do the washing. We use a detergent for that washing.
Yes.
I can't say the detergent we use, but we usually use a detergent to wash this thing, and then it goes to the hot water processing, hot water treatment. And after hot water treatment, we don't cool it down, hydrocooling or something else. It directly goes into the drying and then to the grader. Whether it's a right process or we should include a hydrocooling process in between.
Immediately you have to hydrocool it. Yeah, especially if we are using temperatures above 40 degrees Celsius, you must hydrocool it immediately. So it goes to the hot water, and then getting out of the hot water, it should be immediately goes into regular water. Water somewhere around 20 to 25 degrees Celsius. Never pack it while it is still very hot.
Right. Thank you very much. This clarified a lot of confusion which we had in our process.
Sure. And Dr. Parikh has my email, and I'll be very, very happy, and I'm sure the other experts also. We will be very sure to happy to help if there is anything specific.
Thank you very much, sir.
I will circulate all the emails to the participants. If any other questions?
Hi, hi, namaste. This is Prasanna from.
Myself, Krishna Kumar Kulkarni from FBM Department, Research Scholar, sir. Sir, I listened to Dr. Srikanta sir's whole presentation carefully, and I'm doing the research. And as you mentioned, sir, Sunil sir, if there is some case studies, definitely, sir, that will be like a benefit for we research scholars, sir. So I request on behalf of research scholars in the Niftem particularly to Dr. Srikanta sir, if you have any case studies regarding the value chain management or the value addition, please circulate it via institutes. Thank you.
Someone was asking the question.
Actually, मेरे पास पैसा था भी नहीं.
Yeah, actually, there is some case study we can.
अरे 10,000 लेबर निकल गया, 25,000 आलू को निकल गया, 35,000 हो गया, 5,000 निकल गई.
Sorry, I was unmuted. Okay. So thing is that actually currently we are conducting a project in Andhra Pradesh that is also addressing mango. It is in the middle stage. I think that there from that project we can get some good practical experience that may generate some case study also for valuation development case. But it is in the middle of the project period. So at this moment, from Indian context, there is no, but some other valuation management for other crop, I can check it if there is any possible. Thank you.
Thank you, sir. Thank you.
Okay, Dr. Sudhakar Rao has one question. Sudhakar ji, are you here? You can unmute yourself. Dr. Sudhakar Rao has put a one question that in USA irradiation dosage requirement is 400 gray. Did they lower it to 300 gray now, as mentioned by one of the speaker? Is it 400 gray or 300 gray now?
I think one of the colleagues from the US can answer the now the table that I've shown. It is not what is it is not what is required by each country. Each country can require whatever they like. The table that I've shown, I did not mention any requirement. I mentioned the doses that are enough to sterilize the different types of insects. So the doses that I've mentioned are sufficient to be used as quarantine treatments. Okay? But a country can require something different. Usually the countries require something higher than what is needed. The most obvious case is the heat treatments that we've mentioned. For example, the heat treatments that are being used are much more excessive than what is really needed. What is needed to control insects, for example, is much lower than the time and the temperature of the hot water treatment required by the different countries. But the different countries usually try to require more excessive treatment to make sure that the control is always even more than enough. I hope I made myself clear. So the table that you've seen is not the requirements of the countries. It is the doses that are needed to control the different types of sterilized, better say, not to control, to sterilize the different species of insects. And those doses are always less than 300 grays. Now, what each country requires from you, you have to check from the phytosanitary authority of each country. The US might require 400, who knows what Japan might require, etc. I hope that is clear.
I can, this is Jeff Brecht.
Yeah, it is clear. No, but for India,
Yeah.
USA is asking for 400 gray only. If the requirement is less, then why they should insist on that one, which will increase the cost of this one, like hot water?
I was just going to say that the way the U.S. looks at this is that the first priority is to kill the insects, and avoiding damage to the fruit or vegetable is secondary. So they're very conservative about the dosages that they require. And so quite often, as El-Hadi Yahia said, these treatments are quite marginal and it's easy to damage the fruit. So you just have to deal with that because you can't import into a country unless you follow their phytosanitary requirements. Just have to go online and look up what's required or ask, someone, a consultant or whoever, someone who knows.
Yeah, unfortunately, you always have to meet what the country requires from you, what the phytosanitary requires from you. If they require 500, that's 500. If whatever, it is not, yeah, of course, it is a scientific thing, but usually phytosanitary requirements, as Dr. Brecht says, are always more conservative. It's not only in the state, but Japan is even much more conservative. China sometimes too.
If I can share some more information, in the presentation I gave, I put a link to the Favir website that has the specifics for the irradiation treatment out of India to be able to export mango to the US. And I looked at it right now and it does say 400 grade. So that's what it continues to be. For it to be lowered, because over time science does change, but to get the regulations to catch up with science can be a process. And so if there's new information, it can be presented to governments and they can review it and change those regulations. But that can take time. And as of right now, to ship mangoes to the US requires the 400 grade irradiation levels.
And by the way, 400 is not bad. It's not too high to injure the fruit. You need 500 or more to get into trouble for the fruit. And also the cost is not terribly high. So the cost is really low. The service cost is very, very low. Even much higher, 400 kilograms is still going to be low, and the difference is not very significant. So it's still okay.
Thank you for the clarification. My question is with Professor Yahya. Japan is not in favor of the irradiation, and instead of that, they are allowing the vapor heat treatment. Whereas US, for the export to the US, irradiation treatments are essential. So which one is better, vapor heat treatment or this irradiation?
Now, most of the countries do not recommend irradiation. There is absolutely no problem regarding consumer safety, health safety of irradiation. But irradiation is very difficult from the standpoint of the initial investment. The initial investment is incredibly high. And so irradiation is not a first choice. Heat is a much better choice. It's cheaper. Obviously, it does not indicate to the consumer any doubt about health problems, etc., etc. The problem with irradiation in India and the US is because heat, especially hot water, did not work. The hot water protocols that were tried in India were not very effective for Indian mango. And they tried hot air, and it looks like that it is not the best either. So maybe if research continues to see how hot water or hot air can be done in a way that can make sure of a total control, then maybe the US authority will accept them. But that is why the US insisting on the use of irradiation for mango from India. It is not the case in Japan. Japan is seeing that the heat treatments of mango from India is good enough, and that's why is not insisting on irradiation. If one has to choose between irradiation and hot water because of cost, especially because of initial cost, it is obviously it is easier, it is cheaper, at least from initial cost consideration, to use heat, especially hot water, than irradiation. Establishing a plant, an irradiation plant, is not an easy task at all. It's much easier to establish a hot water treatment application.
Yeah. Dr. Michael, would you like to supplement something?
Yeah, part of the question asked which one was better. And so what is better many times is up to the governments that are setting the phytosanitary protocols. And there are so many things that go into it, politics included, on what's allowed, what isn't. But it's important for the countries to be talking to each other, to be using the latest science, to make sure that we can get the best products to consumers around the world. And so I think the question or the comment was made that Japan preferred one versus another, the US prefers others versus another. Even within the US, there are countries that have more options than others when it comes to the phytosanitary treatment of mango. So it's good to know what those options are. I included the link to Favir within my presentation. And Dr. Parikh, I don't know if I can share my screen one more time, but I could show exactly how the viewers can go in and look at the information and compare what different countries have. Of course, India only has one option, which is the in-country irradiation treatment. But it is always good to see what other countries are doing and see if it's something that other countries would be open to accepting if the science works for them.
Thank you. Then another question.
I have one question on the value-added products. Thanks to Dr. Shrikanta Sheel for explaining it. What is the requirements for us to export the value-added products to the USA? So Favor provides information on the fresh fruits and vegetables, fresh mango specifically. But in terms of value-added mango products, what is that the manufacturer here in India has to know?
Actually, you can find this is a numerical information. You can find the ITC trade map. You can find the trade map website. There is a good information requirement of all of the countries, specific information, specific requirement. You can find. If you write the trade map in the Google search, you can find that website. In one stage, you will register with this website. As a developing country, there will not be any fee required. For the developing country people, the trade map, ITC trade map website is free for registration. So there is good information website for any kind of export import market information and market requirement specification. All those things you can find in that website. Yeah.
Another question is about the ripening of the mangoes. So ripening of the mangoes, ethaphone or the ethyl is also used, and no doubt the ethylene gas is also used. So if the ethyl is used up to the 100 ppm, then it is allowed by the some countries, whereas European Union and some others are objected on that. So what is the exact picture from the safety point of view, particularly that whether the ethaphone or the ethyl can be used up to the 100 ppm concentration for the ripening, or it should not? Yeah, Dr. Yahya, you can answer better.
Yeah, you will give the good answer, I think.
You are muted.
For that. Yeah, I'm sure Professor Brecht also will tell you that, and especially for the American market. And ethyl and ethylene and ethyl and all those types of ethylene sources, alcohol and all those are not permitted, are not, they are not authorized post-harvest treatments. So, and I don't think it's a good treatment either. So it's much easier to use. Don't use gas because people do not know how to use ethylene as a gas source because they don't know how to control it, and it can be it cannot be safe sometimes. But use generators. Generator is very simple, very easy, not expensive, very much controlled, and it's much more effective and much uniform. The gas, the ripening treatment is much uniform. It can be used in a very clean manner. So this is what my conclusion is, and I let Professor Brecht add. Ethylene, ethylene, and all those ethyl are not post-harvest authorized treatments. And I would recommend very much that you look at and use ethylene generators much easier.
The ethyl is considered a pre-harvest chemical, and so the label, which we have to follow, doesn't accommodate post-harvest treatments. So like Ilhadi said, that wouldn't be legal for the US. And the ethylene generators are very foolproof. There is some danger involved in handling ethylene gas because it can be flammable. It's not very dangerous because you have to get up to over 30,000 parts per million in air for it to be explosive, but it has happened occasionally. And with the ethylene generators, the catalytic converter type of systems, there's no danger of that happening. So that would be my recommendation also. Actually, something that's being done more and more in the US, and Manuel Meshel can back me up here. A lot of the retailers in the US are using ethylene to ripen the fruit so that they can be delivered to the retail stores at the stage that consumers want to eat them, and uniformly at that stage. So it's something done quite often here.
Yes, Dr. Brecht, it's becoming more popular each year. In the past, only about 5% of the retailers would ripen their mangoes, going back, say, 4 or 5 years ago. Now we calculate 35 to 40% of retailers are ripening mangoes. And then there are also other companies that provide that service here in the US. So it is becoming more popular, and it helps move the mango faster. It's more consistent quality. The consumer eats it much faster, and then they have a good experience and they come back for more. So it's definitely something worth
Yes, and also the fresh cut mango processors are having their suppliers ripen the fruit with ethylene or without. They're ordering the fruit to be delivered at the proper stage for processing. So that's also part of the mix.
I may add something else because I know a long history in India where historically there are a lot of people who have been trying to push the use of ethyl and ethylene for decades. Don't do that. Even the way of application is not practical. It's not good. It's not. It does not fit into a good handling chain of the mango because you have to soak. You have to soak the fruit, and you don't know when to soak it, before or after packing, etc., etc. It's much more practical, much easier, much safer. The amount of the use of these catalytic generators of ethylene, it's safer because it does not produce more than a few hundred parts per million. So there is absolutely no reason to worry about compared to when you use gases. And don't use calcium carbide. I hope people don't use it anymore. Until a few years ago, I've seen it very much being used in India, especially in the wholesale markets. And the markets don't use calcium carbide that produces acetylene either, because it's not safe, it's not good, it's not uniform. Right? Just concentrate your efforts in a much better method, which is the generators. It's not expensive, and it's uniform, and it's very safe.
Thanks for the clarification. We are not using the calcium carbide. It is also banned not only by the court but by the act of the parliament also. And anyone is not to be used this calcium carbide, but this ethaphone is popularly using. In my lab, we are using the ethylene generators only. But in the market, we have seen that the use of the ethaphone is there. So we have to need a call on that also. And then the other thing is there any future of controlled atmospheres in the mango?
It's already there.
Asking me? Of course, the modified and controlled atmosphere has been used since 1974 for shipping mango.
Oh, for shipping only.
Yes, for shipping only. I don't see any future for storage. It's been tried many times, and I don't see any future for different reasons, especially for logistical reasons. But for shipping, it's been used very often in different countries for no less than 40-50 years. And the problem with modified and controlled atmosphere, unfortunately, there are several technologies in the market, and some of them are very good technologies. The problem is they are almost none of them is used in the right way. And the service providers usually do not know how to use them. And the worst thing is that they don't know how to use it when and how for the specific type of mango, for the specific maturity and ripening stage, etc., etc. They use it sometimes as a pharmacy. What do you call it? They see that textbooks say that 2% oxygen, 5% carbon dioxide, and they use it that way all the time, and that is terribly wrong. And the other thing, they don't really control, most of the technology do not control all the gases, especially many of them do not know how to control carbon dioxide. It's easier to control oxygen, but it is not easy to control carbon dioxide. So it is used. It is effective if it is used properly, if the technology is adequate, and if the application is adequate.
So it is for only the transport, but not for the storage, right?
Right.
Yeah. So thanks. I think there is no more questions, and it is the 6-hour-long marathon meeting. It was, but it is nice. We have covered almost all the aspects in the mango post-harvest processing and the value chain, and we are benefited a lot. I saw that there are the participants from the various countries, especially from the Nigeria. There are the many participants I can see. From the Bangladesh also there are many participants, Philippines and some other countries also. So I thanks to all the participants, and I thanks to all the speakers on behalf of my institute, on behalf of my department, and on behalf of all the participants. And personally, I indebted to all of you that on the very short call, you came here and presented all the things and clarify all these things. Be in touch, and please send your papers to us. That will be circulated and that will be part of the proceedings, and definitely it will be the founding stone for the mango industry, as are all the top policy makers already know that this webinar is held today. and all they invited the proceedings for further work. So with this, I thanks to all of you from core of my heart, and once again we will meet sometime. Thanks. Thank you very much.
Bye.
Thank you. Thank you.
Now I leave this meeting actually.